Father, and of the Son, and of the Holy Spirit. Heavenly Father, we thank you for the gift of life. We thank you for the gift of our parents, teachers, and all those who take care of us. Heavenly Father, here today, we are here for our lesson. We pray that whatever we are taught, we understand and memorize it so that we put it into practice come the day for our papers. In Jesus' name we have prayed with thanksgiving through the intercession of Mother Mary. Amen.
Amen.
Holy Spirit,
Pray for
guide
us.
us. Holy Spirit,
Guide
guide us.
us.
In the name of the Father, and of the Son, and of the Holy Spirit. Amen.
Amen. Okay. Thank you so much, Ruth, for the word of prayer. Good morning, everyone. Thank you so much for sacrificing your sleep to be on this morning call. We are going to, today, our theme that we are looking at numbers. And numbers as the theme or as an element of construct will contain the following topics. So under this theme, expect the following topics. Expect number bases, expect working with integers, rectangular Cartesian coordinates, fractions and decimals, then expect numerical concepts, indices, surds, and then expect ratios and proportions. So these are some of the topics that they can bring for you when it comes to this part of numbers. So whenever you see number one, expect any of those topics, either combined or as an individual topic. However, as we approach this topic, I want you to be able to, that there are some parts that you really need to know that are very common that you are not going to be able to miss. One of the parts that is going to be very crucial is going to be the fractions, percentages, and decimals. Working with integers is going to be very common, and also ratios and proportions. Reason being that they have real life applications. Other topics do have, but it is to a lesser extent. But those three I have highlighted, they have a lot of applications in real life. In fact, we find ourselves that we are using them almost on a daily basis. So many of the questions you're going to be meeting, they're going to be rotating around that area. So, and that's where we are going to concentrate. That is the part that I want us to touch today. And what are we going to start with? Now, I'm going to first summarize for you, and I tell you for many of these topics, what you need to be well conversant with as you go on. Now, the first part is one is going to be number bases. If a question is to be set on number bases, what are the things you need to know? One, you need to be well conversant with converting the bases. Now, under the converting of bases, what is very important that you need to know? One, you must be able to convert, from any base, given, from any base to base 10. That is very important. What do I mean? We know very well that at times they may give you a number. Take an example. They may give you a number whereby we have maybe 222 base 4. So what do I mean? I mean that you must be in position for you to convert from base 4 to base what? To base 10. So what does it mean? It means that, take an example, they have given you this number. Always the first thing you have to do when you are converting bases, it means you must first give them the place values. So take an example, you say this is the place value is 1, this is going to be 1, 0, 1, and then you give it 2. In other words, this is like 1s, 4s, 4, and 4s. So that means that when you are converting such a number to, this is 0, 1, 2. Meaning that when you are converting such a number to base what? To base 10, I will say this is 2 times 4. Here it has a 2. Plus, this will have 2 times 4 power 1. Plus 2 times 4 power 0. Then I'll come here and I say, what will I have here? That I'll have 2 times 4 times 4 plus 2 times 4 plus 2 times any number to power 0 is a 1. So here I'll have 4 times 4, that is 16 times 2, that is 32, plus 8 plus 2. So I will end up with 40, 42. Now take note that whenever you convert from one base to another, indicates that you have converted it, and that is base 10. Much as we know that for any base without a base indicated, it is always base 10. But for your information now, always indicate it there for you to be able to show clarity on what you do. So that is always what you do when it comes to bases. Those people who did Wakata, you might have noticed that there was a need for you to convert. And for whenever you find that, you know very well that whenever it reaches base 10 and above, any base above 10, take an example, base 11, base 12, 13, 14, 15, 16, and the rest of that. Always, when it comes to those bases, the numerals do change. Numerals are like the digits we use for particular base. Take an example, when you are talking about base 4, the only digits that we shall expect you to have can either be 0, 1, 2, or 3. So when it reaches 11, we shall expect that you'll have 0 up to 9. But when you reach at 10, we always represent it using a T. When it comes to base 12, we expect to have from 0 to 9. When it comes to 10 at times you can use T, 11 you can use E. So, but however, when it extends above 11, let me say you're in base 13, here after reaching 11, here they can use any capital letter. Take an example, they can use A, capital B, but always they will define it in the question whereby they will tell you that A represents maybe this numeral in this kind of base. So you need to be well conversant with that. Take an example, I think it was in one of the mock papers whereby they gave you something like that, but they told you that where A represents, I think it was the, maybe let me say 11, B represents maybe 12 in that particular base. Meaning that for you, what you had to do, you have to just give it the place value, check out which base we're dealing it. But now for in that mock I saw, what happened that they gave you the base to which this number was written to, and the base they had given them, they told them an hexadecimal base, meaning that in order for you to be able to do it, you must have you must have gotten to know what the name of the base is, or what base they were talking about. Now, for that case, when they say hexadecimal, that is base 16, meaning that here they're hiding for you 16. So meaning you had to come and I say A times 16 power 2 plus maybe B times 16 power 1 plus 4 times 16 power 0. And then after you substitute what your A was representing, that for this case it was 11 times 16 power 2 plus maybe B was 12, then times 16 power 1 plus then 4 times 16 power 0. Then after you continue with your calculation. That is now about converting from any base to base 10. Then also the second thing you need to know about converting from bases to, you need to know, allow me to use another color now. You need to know how you can convert from, allow me to use abbreviations. This is from base 10 to other bases. Take an example. They can give you your digits when there may be, let me say they're in base, let me say they're in base 10. Maybe the number is 9, and maybe 19, and they want you to maybe to take it to base 2. Meaning that here you need to remember that for me to be able to convert from base 10 to other bases, what should I do? One, you need to remember that here is where we use our base, our number, and the remainder, what you call BNR, whereby B is your base, here is your number, and this is your remainder. Number 2, when you are converting from base to any other number, you need to remember that here always you are going to be dividing repeatedly. You divide the number repeatedly. There is division, or divide the number repeatedly. So that one is also very, very important. Then the last one, you need to remember that when you are converting from base 10 to any other base, you need to be able to always have the remainder in the reverse order. So now that is what you need always to remember. Take an example. In case maybe you have 19 and this is to base 2. So what happens that here your your base is 2, your number is 19, and your remainder. Now what you do, you keep on dividing repeatedly until you reach a point whereby the numerals you are getting are below 2, because in 2 we only work with two numerals, 0 and 1. So here you say 19 divided by 2, you'll end up with, I think this is 9, and which remainder will you get? It will be 1. 9 by 2, here you'll get 4, remainder 1. By 2, you'll get 2, remainder 0. By 2, you'll get 1, remainder 0. So meaning that 19 base 10 into base 2 is equivalent. Then we take back the remainder in the reverse order. So you'll say 1, 0, 0, 1, 1, base 2. So that is what you need to remember when it comes to changing or converting from base 10 to any other base. Now, number 2, please make sure that the names are familiar to you. Yes, the names are familiar. They may use a certain word, and if you are not familiar with that word, things may not work out much as you know what to do. Now, what are some of the common names that I want you to take note of? One, the common names, I want you to always relate, try to relate that when they talk about the common one can be, let me say 3. When we talk about 3, it comes from try, T-R-I. So T-R-I, like the way you see try. So try is what you call 3. We call it the trinary base. So now here, when you see the word trinary, those people who trinary, it comes from 3. So that is the word you need to know. When it comes to 4, you need to know that quarter. So you try to relate the word with the base, quarter. Quarter means what? 1 out of 4. So that one means that is base what? Base 4. When it comes to 5, the word is queen, queenale. So you need to just relate. Then 6, it is sex more. Now those people who are doing Latin, I know you shouldn't be able to fail these bases, because when you look at these bases, more or less in Latin, if you know the Latin numerals, that 1 is called unus, then 2 is called duo, that 3 is called tres, that 4 is called control, that 5 is called quinale, that 6 is called sexy, that 7 is called septem. So if you know Latin, those people who have some idea on Latin, those bases are named in that order. So those who don't know, then now for you need to relate that when I talk about 7 is septimo. When I talk about 8 is octo. That is octo. When I talk about 9, that is nonale or nonale base. When I talk about 10 is decimal. Now from that one, when I talk about 12, 12 is duodecimal. When I talk about 16, 16 is hexadecimal. Now you need to know, to have an idea about those names, because in case they use any of those words, then it can be easy for you to relate. So like the other mock I was telling you, they use this word hexadecimal, and people went off. Students did not fail because they didn't know, but because the word that it was used, they were not able to remember. So, but which one do you need to know? One is the decimal. Please, that one have it in your head. Decimal means base 10. At least that one you should know. Then the rest, try to have them in your name. So now this is briefly what you need to know when it comes to number bases. You can add on other information, but I want also to remind you that when they talk about number bases in simple terms, they are looking at grouping things or heaping, putting things in heaps. That's what you call number bases. So for you, whenever you group things, let me say in base 2. In base 2, it means that you are going to group things in groups of 2. That 1, 2, 1, 2, 1, 2. So that is the meaning. That base 2 means you group things in groups of 2 or in heaps of 2. When they talk about base 4, it means here you are going to put your things in groups of 4 or in a heap of 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That is the meaning of base 4. When it comes to base 10, it means that you are grouping your things in heaps of 10. So do not cram. So for you, you need to know, if you have ever seen those ladies who sell matoke, who sell the matokes, who sell one thing, one finger of matoke, you have noticed that always they group their things, they put maybe, I don't know now the cost, you'll find them, they are putting about 6 matokes for 1K. So they are arranging them in a given base. So when you find that they have, when you look at, let me use these cartons of soda, you find them that they are grouping them, that each carton has 12 bottles, or 12, I think. So that means that they are grouping them in groups of 12. So that means they are working with base of 12. So whenever you see the word heaping, what, that means we are working on bases. Okay, let me hope that is very, very fine. Okay, now I'm going to continue. The next part is going to be here, working with integers. Now, working with integers, what is going to be very common? They are going to be testing you. Do you know how to write in words? Or do you know how to write in figures? But the most common one is you being able to move from words to figures. When they say 3 million, are you able to write it in figures? That is what they are going to be testing you in. So now you need to be well conversant with how we write from, how we move when you are given words and you are going back to what? To figures. That's what they are going to be testing a lot. So you'll find that they have put a scenario, but in that statement, they have said that maybe Daniela went to the shop with 750,000. So if you don't know how to write from words to figures, it means that you'll not be in position to pass that particular what? That particular number. So you need to know when they say that 350 million, how do I write them? So that is writing in words. Then these two are going to be very common. What you call the HCF and what you call the LCM. When we talk about HCF, we are looking at the highest common factor. And when we talk about LCM, we are looking for the lowest common factor. In simple terms, when they talk about lowest common factor, we are looking at that smallest number that can evenly be divided by 2 or more numbers. That's what we call the lowest common multiple. When we are looking at highest common factor, we are looking at that largest number that can evenly divide 2 or more numbers. Take an example. In case we are looking out, let me use 4 and 6 as my numbers. When we are finding LCM, please use any approach you are very sure of, but allow me here to use the ladder approach, whereby I have 4, I have 6. When I'm looking for LCM, always what I do, I'll get these numbers, then I say maybe by 2. I look out for any multiple. So by 2, 4 will go into 2, here it will go into 3. When I say by 2, here it will go into 1, here it will remain 3. By 3, here will be 1 and 1. Meaning that here my LCM is going to be all these numbers, which is going to be 2 times 2 times 3. So this will be 2 times 2, which is 4 times 3, which is going to be 12. Now it means that the common multiple between 4 and 6 is 12. Hope that is very okay. However, when we are looking for HCF of 4 and 6, what do you need to know? Here we have very many approaches. Always use the one that is easy. HCF must be that factor that can go through both numbers simultaneously or at the same time. Take an example. When I say by 2, when you say by 2, here 2 goes into, you get 2. 2 goes into 6, 3. That means that 2 is one of the factors, meaning since it goes into 4 and 6 at the same time. But when you continue here, you are noticing that 2 will go here, but it won't go in the second number. It goes through, when you check very well, you are noticing that 2 is able to go through here, but it can't go through here. So when you continue by 2, you will get by 2, here, when you continue by 2, here you get 1, but here you get 3. And here you get by 3, you get 1 and 1. But when you look at 3, 3 only goes through here, it doesn't go here. So meaning that here, this one cannot qualify to be the common factor. This one will not qualify. So you only take that number that goes through both numbers at the same time. So here you just conclude that your HCF is going to be 2. or you can use the other approach. So that one is very, very important. But when it comes to these things of HCF, LCM, after you knowing how they come about or how to calculate, what is important, you need to remember that here we are now using words. They will not tell you directly, find the HCF of 4 and 6, find the HCF of this and this, but you instead need to remember or to know how to do it. Allow me to first speak, Ryan. Yes, Ryan.
Good morning, teacher.
Yes, good morning.
Teacher, what if you get when a number is divided two as divided throughout two times?
Yes, also you take
Like,
it. You take it. Take an example.
like when you get two HCF.
Okay, what I'm saying, take an example. Let me say let me use 12 and maybe 18. Now here, when you are finding your HCF, when you say by 2, here you will get 6. Here you will get a 9. When maybe you say by 3, here you will get your 2, here you will get your 3. But here by 2, you get 1, here 3. By 3, you get 1, 1. So here you are going to notice that at the first step, 2 goes through 12 and 18 at the same time. So this one qualifies. When you go to 3, 3 goes through 6 and 9 at the same time. It qualifies. When you go to 2, 2 goes through 2 but doesn't go through 3. So this one doesn't qualify. 3 here goes through this but doesn't go here. So it doesn't qualify. So now you come and say, my HCF is going to be 2 times 3, the two numbers that go through, and it will be 6.
Okay, thank you, sir.
Okay. 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 Now we can continue. Now we go to the most important thing. I've told you they will not ask you find the LCM of this, but you need to identify. Now this is where I want you to understand. What are the applications of CF? What are those things that you must look out for in the question? And you get to know that here, this is what I must find. Here I must be finding HCF. Here I must be finding LCM. These are the words you have to use. Whenever we are dealing with LCM, we always look for things that involve splitting. Whenever you find that you are going to splitting is like dividing something, is like sharing something. Anything that involves splitting, things that involve dividing, things that involve sharing equally, that means we are looking out for HCF. Whenever you find a question whereby you are noticing you are going to be dividing things into equal parts, please, that question requires you to find HCF. What are some of the keywords you look out for? You look out for splitting. You look out for the words like equally distribute. You look out for how many people we can invite. You look out for how to arrange. So such things involve yes. So those such things will involve things concerning HCF. And how do we do it? Or what are some of the applications of CF? When you look at the questions that involve cooking, things that involve packaging, things that involve fencing. Now here, fencing can be a bit of common. Take an example. Some of you have farms at home, whereby they may tell you, your father's farm is maybe 30 meters by maybe 40 meters, but he wants to put a fence around, and they ask you, what space should the poles be such that they are distributed equally? You know, a farm, like always on a farm, we have poles. So they may ask you, what distance should these poles be from each other such that they are distributed equally? So that question requires you to find the HCF of 30 and 40. So for you, the moment you find that it has dividing, now even it comes to pieces of cloth, when those people who are doing tailoring, when they are cutting and doing those things, they always involve use of HCF. So for you, the moment you see things, as long as you look at the idea, when it involves splitting, when it involves dividing, then please just know that one will require you to involve in what you call HCF. Number 2, when it comes to yes, so that is HCF. Allow me to, okay, just a minute. Okay, just a minute. Okay, this. Okay, now, what about when it comes to LCM? Now, when it comes to LCM, for it involves things that repeat themselves, or what you call repeated events that are going to repeat themselves after a given period of time. So for such a case, they will require you to bring in HCF, things that are repeating, that is involved. Take an example. I think you have seen these questions whereby they have told you that Joseph exercises every 8 days. Gabriel Guma exercises every after 4 days. And then they can ask you, Joseph and Gabriel both exercise today. How many days will they exercise again? Now, those things that involve repeated events, that involves things of repeating, of meeting again, it means you're going to be finding the LCM. Now, for such a question, it means that it will involve you finding the LCM of 8 and 4, such that you know that after how many days can Joseph and Gabriel meet. So please read the question. For you see events, you see things of that nature, then you need to know that I'm going to apply LCM. LCM, you can find applications such as like in baking, cooking, scheduling events. Even here, it is very common when it comes to traffic lights. They may ask you, at what time will they light again? Those things of traffic lights, sequences, fitness and exercise, those are all applications of LCM, whereby you find fitness or exercising, whereby you find the traffic lights, when you find the timetables of vehicles, of buses, and the rest of that, when you are scheduling an event, all those ones are applications of what you call LCM. Even people are going to be into baking. Yes, when you are making your recipes and the rest of that, you'll find yourself that you need. So when it comes to LCM, it involves the main word I want you to know is repeating. When are they going to meet again? Yes. But when it comes to HCF, here it involves a lot of splitting. Like even you have been to parties, at times when they're inviting people, always they first look at the resources they have. They say, we have 5 kilograms of meat. We have 2 kilograms of rice and maybe this. How many people should we invite? Now, for them to find out how many people to invite on the party, it means that they need to involve in the knowledge of HCF, because when they invite people, they want these people to share equally everything they have. That let everyone get some piece of meat, let everyone get some piece of maybe some piece of chicken, let everyone get on some. So they look at the resources they have, and then they look out for how many people they can invite to attend that particular party. So it is very important now for you to know where you are going to apply HCF and where you're going to apply what we call LCM. Okay, let me first answer. Nobody.
Good morning, sir.
Yes, good morning.
When I was there's a certain mock number I did with my friend at school, and it was applications of LCM and HCF. But for us, we never knew what it really wanted, like LCM or HCF, and we attempted the question with another approach, and we still got the answer. Is it okay?
It is okay, given that the answer you got was correct.
Okay, sir. Thank you.
Yes, Kigez.
Good morning, sir.
Morning.
My question was concerning your application. You talked about the different ways in which this LCM or GCF can apply in these questions day to day. But I was asking also if vessels maybe can apply.
Which one?
Like vessels.
Vessels.
Yes, like when they say the largest vessel that would be used to distribute, let's say.
Yes,
like
that
some
is.
kind of question.
Yeah, that one applies.
All right, thank you.
Yes, that is HCF. The moment for you see things concerning distributing, sharing, as long as there is something of division, even in construction, when you want to find out which kind of tile can fit in your room, what, such that there is no space left, those are applications of HCF.
All right, thank you, sir.
Okay. The last one, Safra.
Good morning, sir.
Morning.
I'm just asking about, like, there is a question I also did
It was about repackaging. So in case they bring that question, because we had to first find her the hip she repackaged and what and the money she got, and then the gross profit. Can you apply this method in that question?
Yes. Now packaging is more is in HCF. Packaging, yes.
Thank you, sir.
Okay. Lastly, Jackie.
Okay, good morning, sir.
Good morning.
For me, I would like to understand that there is a question that you found that the trees were planted. So the question demanded us to find that the number of trees that can fit in the garden when the first row is planted at the same line. So what application should we provide for that one?
Now, now that one still will come in HCF. Then to find how many trees can go there, you'll apply still the same knowledge.
Okay.
So when it comes to but we are going to look at some examples. We are going to look at some examples. Yes. Whenever you want to do something to maximize, whenever you want to maximize the space you have, all those things of maximizing, it means that you need to apply the HCF. You may find yourself you have a small piece of land, but you want to maximize it very well, such that you don't waste space. That one involves, it means that you must distribute your things equally. In case you have your small room, maybe of 30 by 40, and you want to buy tiles such that you don't waste and that they fit. In order for you to know the size of the tile to put here, you use HCF. For you to know how many to buy, you'll need now to use the same knowledge. So please, that's what we are going to do. Take an example. I have here a question. I want you to put in the chat, which application is this? HCF or LCM? Let me see what. Read through and put in the chat. I want to see which application is this. Yes, very good, very good. So whenever it comes to, yes, this is very good. Now you're understanding. So whenever it comes to the maximum number of things that can be put in each group, it means that now here there is some kind of splitting, that you have 28, you have 42 and 56. So you want to split them to find out how many you should have in each group. So that means that when it comes to splitting, such that you know how many people should be in each group, it means you are going to apply HCF. So for such a number, it means you are going to find out the HCF of 28, 42, and 56, because it involves dividing, distributing, and the rest of that. Okay, I have another one. We have another one here. I want you to read through quickly and tell us which application. They are telling us that Joseph wants to tile the floor of his living room and bedroom with square tiles. The room measures this, while the bedroom measures this. So they're asking, what should the size of the tile be? So when they talk about dimensions we are meaning the length and the width, or height, in case that given figure has the height. So which application? LCM, HCF, which is which? Now you need to know to find, because remember, people were saying, now LCM will determine. Now here, I want you to take note. I want you to understand that in order for you have your room, to know the size of the tile that you can put in such that you maximize the space you have, it involves the idea of splitting. Yes, so you are going to divide the space you have such that you get exactly which square tile can fit in. So this particular number requires the use of HCF. I've told the moment you see things of dividing, splitting, it means that you need to use the greatest common divisor, or what we call HCF. I've told you LCM only applies whereby we need to find out how things that are repeating themselves. Yeah. So, but to find out the maximum number, to find out how many you should have, the space between what and what, then it will involve the use of the HCF. Good. Now I can look at an idea. This was one of the mock papers. We are not going, I want you to first read through. They told us that Simon is the district inspector of schools in Mitoma district, owns a farm that measures 308 feet by 228 feet. He plans to put a fencing posts along its sides at equal distances apart. One day, Simon discovered this and this, but I'm interested in question 1. They're asking us that help Simon to know the greatest distance between the fencing posts. So now, when you look at this question through the chart again, what is the question requiring us to find? That space between the poles, what should it be? Very good. Now, it means that for this particular number, you are going to come and I say, number part A. I'm going to find, I can say that, to find the greatest distance or the distance between the two poles. It means that I will need to find the what? The HCF. So you will come, it depends on the approach, you know. So you say this is 308, and then this is, they gave us what? 228. Then for you come and you do either your ladder or any other approach, you know. So I say, now what factor should I start with? Let me say 2. Then you divide, you say 308 divided by 2, I'll get my 154. Then I say 228 divided by 2, I'll get 114. Then I continue by 2, here I'll get 57. Then I'll come here, 154 by 2, I'll get 77. Then I ask myself, is there any other number I can 2 still go through? 2 can't go through both numbers. Then I say maybe by 7, I'll get 11. What about 57? 57 by 7, it doesn't go through. So I remain with 57. Then maybe I ask myself, which number can go through 57? Maybe I don't have. Then here I say, maybe by 11, I'll get 1. Here I'll get 57. Then I ask myself, is there any number that can go through 57? In the chat, let me know. Do we have any number that can go through 57? Quickly? No. Daniela is saying no, 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 no. So meaning here, we shall say by 57 itself, we shall get 1 and 1. Then after doing so, you are going to ask yourself, which numbers are going through at the same time, both numbers simultaneously? So I'll come, I ask 2. Is 2 going through this and this at the same time? Yes, that 2 went through, we got 154 and we got 104. Then you tick it. You say that number is very okay. Then you go to the second one. Does that 2 go through both of them simultaneously? That yes, ta. Then you ask, does 7 go through simultaneously? That no. Does 11 go through simultaneously? That no. Does 57 go through simultaneously? That no. Then you say, now, my highest common factor is going to be these 2 numbers that are going through both numbers at the same time. So it will be 2 times 2, and that means I'll have my answer as 4. Therefore, I'm going to go on and I say that, remember, they gave us in feet. So I say it's going to be feet. Then I'm going to come back to the question, and then I answer it correct, and I say the distance between the fencing posts. So remember here we are dealing with a pose. So I'll come and I say that the distance between the poles should be, okay, sorry. Here I'll come and I say that the distance between the poles should be 4 feet. Meaning that when they're spacing them, let me say this is the first pole. They are going to be jumping 4 feet to the next one. So this is going to be 4. They will jump 4 like that, like that. So that is the meaning. So even they can go on and ask you, how many poles shall we need? Maybe along this side and along this. Maybe this is the length and this is the width. They may ask you, how many poles shall we need along the length? Then you will come here and say that we shall have 308 divided by 4. So now you know that 308 divided by 4, how many poles will you need? You will need about 77. Then what about the other side of 228? How many poles shall we need? Then you divide. So that is what you have to do. Yes, Simon.
Sir.
Yes.
I've seen the series can be divided 57.
3
can divide 57.
3 can divide 57. Okay.
Yes.
It is okay. Yes, but still when you look at 3, 3 cannot divide simultaneously. So if you want, you can remove this and then start by 3. But it's going to take time now again because it has to go through 3, then 19. Are you getting it?
Yes.
So meaning that for you, you have here, but if you consider to take 3, you'll have 1. So here you'll get 19. Then after you say by 19, 1, 1. So still these 3 can't go through simultaneously.
Okay.
Okay. Okay. Yes. Okay. So Jonathan, I'm using this to show you that you can continue until you see that there is no any digit that can go through simultaneously. Yes. So the rest, that is how you do it. So when they ask how many poles shall we need, then you need to know that along the length, how many do we need? What about along the width? How many do we? Yes. Yes, how many do you need? Yes, someone is asking, what if you stop on the numbers that go through? That is very fine. There's no need why you should go through, why you should go up to this step. You can stop here where the numbers do end. So that is what you do. Then when they ask you, how many poles will this person need? Please just know that if along the length you need 77, then you come and say, what about along the width? So you divide by 4. So you say 228 divide by 4, that maybe there will be 57. Then when in case they want the total number of poles that they need, then that means you need to know that I'll have to get the ones along the length and then along the width. So that is what you need to know. Yes, Roy Namakula.
Good morning, teacher.
Good morning.
I'm asking why are we dividing by 4?
No, here I'm using an example. I've told you that in case they have asked you, how many poles shall we need along the length? Are you getting it?
Yes.
That's why I was telling you that what you do, you get the HCF you have got, divide by the size of the length. Hope that is okay.
Okay, thank you.
So that's what I was trying to explain. Nicholas? Okay, I'm not getting Nicholas. Yes, morning.
So what if we decide to use like the big numbers instead of these small numbers, like 2 side to side from 4
It is
and
okay.
above?
Yes, it is okay. As long as for you now, you cannot quickly that 4 can go through both of them. It is very fine.
Yes.
Okay. Yes. Rachel, HCF is the same as GCF. They're the same. Last, Daniela?
Teacher?
Yes.
When they ask me for the number of poles, do you multiply by 2 because they are 2 lengths?
Do you multiply?
By 2 because they are 2 lengths.
Because they are 2?
Oh, somebody's mic. Because I'm saying because there are 2 lengths and there are 2 widths. So do you multiply by 2? Maybe 7, you know how 77 is for the length? So it says 77 times 2.
No, now, remember, they are not 2 poles.
Because
No,
the length of the farm. The length.
Oh, no. Like they told you, the size is 308 feet, and this is 228 feet. Not so?
Yes.
Now, to find how many poles you will need this side, you would say 308 by what? By 4, which is 77. Then, but also this side, you need how many?
7. That's what I'm saying. 77.
Oh, okay. Okay, yeah. It is fine. Okay. Okay. I think now we can continue. Alovic. Okay. Yes. So now these are some of the applications. So those people are going to be doing things in construction. When they're making quotations, they ask you, depending on your piece of land, how many poles shall we need in budgeting processes? You'll need this kind of idea. Okay, now that was briefly about HCF and LCM. So it is very common in many numbers that you are going to be meeting. But on that number, I was interested to just show that. Now we go to the next part, is what we call the operations, or what we call fractions, percentages, and decimals. Now, when it comes to this part, the most important thing that you need to know in this topic are what we call the operations on fractions. Under the operations for fractions, it means that you need to know the addition, how we add fractions, the subtraction, the division, and then the multiplication. These ones are going to be very common when it comes to operations of fractions. You have seen that for many numbers, when they bring for you, they will tell you that half of those people went in for this, and then after the remainder of this and this. So you need to know, how do I add fractions? How do I deal? So I expect you by now, everyone to be knowing how you can add fractions, how you can subtract, how you can do the division, and how you multiply. Then when it comes to percentages, here, the most important thing you need to know, how to multiply a percentage. When they tell you 50%, you need to remember that that is 50 out of 100, then times something they have given you. So you need to know those two things are very important in this topic of percentages and fractions. Then the most important part is what we are going now to call the ratios and what we call the proportions. Now, at your level or at this level, there are basically two things you need to know under proportions. Under ratios, I think this week we have looked at a few of ratios, but ratios, it is mainly concerning how we do the sharing. Then under proportions, the two things I want you to pay attention to is what we call a direct and what we call an inverse, or what you are calling an indirect proportion. Now, when it comes to a direct proportion, I want you to take note that here the keywords they can use, they can say maybe the piece of land varies directly. So here they can use the word directly, they can use the word varies. Then also, when it comes to the inverse, or what we call indirectly, here the keyword they will use is the word indirectly. But the most important thing for you to know is that when it comes to direct proportion, one quantity increases as the other quantity also increases, or one decreases as the other quantity also decreases. Take an example. That is what we call the direct proportion. An example can come, let me say, when you are traveling, the more distance you cover, the more fuel you use. That is what you call direct proportion, that more and more, less and less. When it comes to inverse proportion, here inverse proportion, here you can look at, let me use students, let me use now a student, and here for the students, you can use an example that I wanted to use this one, that when we are getting towards the exams, you find ourselves that our weight is going to reduce, because the more the pressure, the less the weight of a person. That when the pressure is piling up towards the exam, you'll find that many of you are going to start losing weight. So here you have more and less. So that is very important. Take an example. I can use another example when I'm talking about time and speed. You may look at when we are talking about time and I'm talking about the speed. You'll find that the more speed you use when you are driving, the more speed, the less time you'll take. So that means it is indirect proportion. So when it comes to direct proportion, do not forget that under direct proportion, we shall always write our equation maybe in this format. But when it comes to indirect proportion, our equations are always in this format. So those two things are going to be very, very crucial for you when it comes to proportions. Now, at this level, you on your syllabus, you do not have when it comes to partial fractions. Now, partial fractions, I don't want to go deep into it, because here the only thing you need to know is how you can combine maybe an inverse and something. But here, mainly concentrate at those two things, direct and then the inverse, because that's what is being provided on your syllabus. Much as I saw in some of the mock papers, they set something beyond what you are supposed to cover in your syllabus. Yeah, but it is very okay. Knowing something about it can as well be of help. Now, how do we deal with this? I have just picked one question that I got interested in that was combining understanding and knowing about direct and inverse. And that is the question I want us to start with. So this question combines those two aspects that I want for you to understand, that it has the part that will involve you to involve in the critical thinking, but also to involve in the idea of direct and the idea of the inverse. You can first read through the question, everyone, as I pick this hand. So let me first pick Amal.
Yes, good morning, teacher.
Good morning.
Yes, I wanted you to repeat on the operation on fractions.
Operations. The adding, the subtraction, dividing, and multiplying.
Yeah, how do you mostly like bring operation on fractions? I do not understand.
Oh, okay. We are going to do some scenarios.
Okay.
We are going to do some scenarios on that. Hello, Vic.
Okay, sir. Good morning.
Good morning.
There's something I wanted to consult about the LCM and HCF. Now, there's something when you are dividing, you add either one or subtract. On what condition do you do that?
It sounds a bit new to me. When you are adding, you subtract one or you add one?
When dividing by HCF, you are getting number of fours. There's a condition where you add one and there's where you subtract one, but I don't know on what condition. I've ever come across it, but
I think I just need to, maybe, if you can give me a question where that I may need to first interact with, but maybe allow me to make more research about it, and then maybe I will give you feedback on the WhatsApp group. I need to first know why. But that number, I think if at all I can relate it, a bit. Yeah, I think there's something I'm trying to relate it, but I'll give you some feedback. Let me first find out, but that one is mainly maybe when you are neglecting the corner points, when you are neglecting the corners, because you may not have a corner. Okay.
Okay, fine. Thank you.
Okay. Yeah, okay, now we are going to start. Now they're telling us that a hotel in Kayawe town feeds 200 people every day. They normally store their food. They mainly store their food, and it can take them 15 days with the 200 people. Meaning that this hotel plans that in 15 days, the number of people who come to take their meals are 200. So when they're buying their food, they only prepare for those particular people. Now they're telling them that during the festive season, the number of the people in Kayawe surge. Surge in English, I think it just means something that increases abruptly. I'm sorry about that. Unfortunately, when I was logging in, I forgot to plug the Wi-Fi into the socket, so the battery ran out. So that's why I was off. Okay, but I've plugged it on. Okay, let me hope my screen is on. Hope my screen is on. Okay, hope my screen is on now. Yeah, okay. Now I was still saying, so now we are interpreting the question. Now they're telling us that it was divided into fixed cost and a variable cost. When they talk about a fixed cost is that cost that you incur even if you are not into production. An example, like there are some expenses you have to meet at home, even if you have not cooked. Let me use an example of cooking. There are certain things there are some costs you are going to incur at home, even if you have not done something much. An example is water. You'll find that every day you have to use water, whether you have cooked or not. So there are some, we call them fixed assets or like fixed costs, those small things that you incur even if you have not produced anything. So those ones, we call them the fixed costs. Now, what does it mean? It means that this particular thing, that if they are operating or when they're in operation, there are certain costs that must go. Take an example, you'll find that they have to use maybe water. And then there are some things that vary. Take an example. Here is maybe when you use electricity. Another example I can use, take an example. You may find that these people are renting. When it comes to renting, you know that a rent is fixed, that every month you are going to be paying your maybe, let me say you are paying 200. So rent is a fixed cost that every month you are going to be paying that 200,000. So that one, you must have it. Then you can add on another thing that maybe other costs may come in depending on the electricity you use, depending on the water you use, and other things, other expenses. Now take this example of rent. It can work very well. That in order for you to determine the costs that you are going to use in a particular month, you always add the rent you pay, which is 200,000. Then plus other costs that can come in. Take an example, water, maybe health, maybe take an food, take an example of electricity. Now, all these ones always change depending on how you have budget, how your month has gone. But the rent, whether your month has gone well or bad, you must pay the 200. So that is the meaning. Then variable means something that can change, things that keep on changing, things that keep on varying. That's what you call the variable costs. Now they're asking us, when you read through, they are telling us that now they are determining how long the food in the store lasted when 50 more people started eating in the restaurant every day. Now you need to know that at first, here we have two things. Here, I'm going to use this space. Here we have one. We have people, the number of people who are visiting the hotel. We have the days, not so? So we have people and we have the days. These are the things that are going to be our varying variables. Now, the first thing always you do when you are starting these questions is that first understand which topic is this. So when you look at this topic, is the topic of ratios and proportions, meaning that under the strategy, you must apply those topics. So the first thing I'm going to say is that let the number of people, because here when you read the question, they're asking how long. It means that they're asking the days when 50 people have joined, meaning that the things that they are looking for are the number of days and the number of and the people are the ones that are varying. So those are the two varying variables I'm going to use, people and the days. So I'm going to say that let the number of days be represented by D. Let people, the number of people who visit, be represented by P. So P is representing people and the D represents the days. Now, this is why now you need to ask yourself, which kind of proportion is this going to be? initially, the initial number of people was 200 and they had planned for them for 15 days. Now ask yourself, when the number of people increases to, because at first they were 200 and more 50 people have joined. When the number of people increases, what happens to the food? Will the food increase or the food reduces? Put in the chat. Yes. When the number of people increases, will the food increase or the food will reduce? And what will happen to the days? It will reduce, increases, increase. That means that the food must increase. What about the number of days? Remember, they have planned for 200. What will happen to the number of days? The days reduce. Days are going to reduce. Now here I'm going to say, this is where the reasoning will come in, that the higher, here we are going to agree that the higher the number of people, because those are the two things, the higher the number of people eating from the restaurant, what is going to happen? The lower or the less the number of days. Because remember, their initial plan was for 200. That means that when more people are coming, it means that the days are going to reduce. So when the number increases, the days are going to become less. Instead of the 15 days, you'll find that now this food they had prepared for is not going to be enough. So the higher the number of people eating from the restaurant, the less the days that the food that they had budgeted for will last. So this kind of proportion, let me know in the chat, which kind of proportion is this? Which kind of proportion is this? Where we have more, an increase, and then another factor is reducing. Okay, very good. So this one is going to be an inverse proportion. So now I'm going to write it. I'm going to say that people is inversely proportional to the days. That as the number of people is increasing, the number of days are going to reduce, because initially they had only budgeted for 200 people. So here I'm going to come and I say people is equal to, we say that when we are removing the proportionality constant, we introduce in the K. So we shall say K out of D. Now this is going to be your equation. Then you go back to the question that a hotel in Kayab feeds 200 people every day. So now we shall come and say that the number of people P initially was 200. And the number of days they had prepared for were for 15. Then we find out what is our K, where K is the proportionality of constant. So here you'll say K represents the proportionality of constant. So now here I'll come and I substitute. Where there is P, I put 200. Where there is D, I put 15. So I'll have 200 is equal to K out of 15. Now, in order for me to get K, it means that I'm going to be multiplying or I'm going to cross multiply. So what is going to happen? I will say 200 times 15 is equal to K out of 15 times 15. So I've multiplied 15 on both sides. So this 15 and this 15 will cancel. So when you place your calculator, 200 times 15, you'll end up with 3,000. So meaning that 3,000 is equal to your K. Now, after getting K, you go back in your original equation and you substitute. So meaning that we shall have P is equal to 3,000 out of D. Now that is the number of people will equal to 3,000 out of the D. Now afterwards, they're asking you, determine how long the food in the store lasted when the 50 more people started eating. Now you're going to ask yourself, now what are we looking for? We are looking for P. We are looking for the D, the number of days, but they have given us P. Now, can you let me through the chart? What is going to be our P? How many people are we going to have for this time round? If 50 more people add on, how many shall we have? Yes, 200, Baleke, 250, very good. Yes, since we have got new people, we shall say now here, 200 plus the new people who have added on. So here, we shall end up with 250. Now we come back to our equation. Where there is P, we put 250. So here I'll have 250 is equal to 3,000 divided by D. Now, the moment we reach this point, we are looking for D. So I cross multiply or I multiply on both sides. So when I'm multiplying on both sides, because I want to obtain, I'll say this side times D times D. So when I times D, this D and this one will cancel. So meaning that what am I going to remain with? I'm going to remain this side. I'm going to have 250D is equal to 3,000. So after I divide by 250, I divide by 250. So mean that the number of days is equal to, what are you getting? What are you getting? 12 days. 12 people are getting 12. So I will say is equal to 12 days. So now I'm going to conclude and I say that the food will last for only 12 days. But also you reason out. Take an example, you get your answer as 20. You must reason as, how can it be 20? How can it be 20? So you need to keep on reasoning such that you are within the range. So that is how you attempt such a number. So you reason, but here the strategy is very important. The strategy is very important for you to know that now, for this particular number, this is what I need to use. That for this particular number, I needed to use this. So you must first reason out. And now, are you seeing this statement I've put here? That statement can help you because we said we always look for what makes you an extraordinary person from everyone. So now you putting that statement, it shows an understanding that what you are doing, actually, you know it very, very well. So that's how you attempt part A. So when they are awarding you marks, they are going to award that has this. So they are going to ask, as this person here, they are going to ask, as this person used the right strategy? That yes, then that means you are going to be able to be awarded. So it is really very, very important. Very important. Okay, now we go to part B. Now, when I go to part B, they're asking us, form an equation relating to the total cost, fixed cost, and variable cost. Now, we say that when we are talking about a total cost, they told us that the costs this person is incurring are composed of two things. A fixed cost, something that does not change. An example I've given you, rent. That if you are renting in a room, there are things that are going to be constant. That example I've given you, your rent fee, the 200 you are paying, or 100 or 50,000. But you keep on adding. If you are calculating the total costs you have incurred in a month, you add that fixed cost of the rent plus other costs that's coming. That here I have food, I have what, I have this and this. So you keep on adding on all those things. Now we go to, okay. Give me, okay, let me first make some duplication here. Okay. Wanted to make some duplicate and then, okay. 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 Now we are going to go to this second part of forming an equation. Now, okay. Now, when we are forming an equation, it is always very important. It is always very important, but this screen is going to look ugly, but it is okay. I will change. Now, it is very important for you to first understand. What do you need to understand? One is to understand what are we going to do. Allow me to first cancel out this. Now, the statement is here. The hotel also operates a machine and here. So here they have told us that the fixed costs is what they are representing by Z. Then the variable cost, things that are changing, variable cost is what they are representing by K. Now, for us now, because I told you we must always define. So I'm going to say, let the total cost be capital T. Meaning that in order for us to get the total cost for everything, I will say that the total cost is going to be my fixed cost plus what you call the variable cost. So here I've used that thing of the rent. So fixed cost is your rent plus other expenses you incur at your home. Now they have told us now, when I'm substituting here, a fixed cost is Z. So I'm going to come here and I put Z. Then I'm going to come here and I say plus. What is the variable cost? Then I read. They told us that the fixed cost is the cost the hotel incurs even at zero level of production. And the variable cost is directly proportional to the volume of the juice sold. What does it mean? It means that in the production, as they are producing the juice, the more they incur more costs. That is like more electricity goes and the rest of that. So here I'm going to say the volume of the juice, let us represent it by V. So what does it mean? It means that when it comes to variable cost, we are calling K. I don't know whether people are seeing K. The variable cost which we are calling the K, here in our equation, the K, they have told us that K is directly proportional to the volume of the juice. That the more juice you produce, the more costs you incur. So in order for us to remove this proportionality constant, allow me to say that now K will equal to, here we say that when you are removing the proportionality constant, you introduced in a number, what we call the proportionality constant. Allow me to use a number, maybe MV, whereby M is my proportionality constant. So it means that here in my equation, I'm going to have Z plus, where there is variable cost, I'll put MV. So here I'm going to put MV is equal to the total cost. Kindly, may I know in the chat whether we are together on that equation? Let me know in the chat. Are we together on that equation, everyone? Yes, yeah. Okay. No, some people are saying no. Allow me to repeat it a bit. Allow me to repeat it. I'm going to duplicate again because it is very important and we don't want to leave anyone behind. I want to allow me to repeat it such that we are at the same page, such that we are on the same page. Okay, I'm coming back. Now, they have told us, I repeat here, from here, they told us that the total cost from here, that the hotel also operates a juice machine whose cost of operating is divided into fixed cost and variable cost. So I'm going to say cost of operation. Cost of operation. They are telling us that you must get your fixed. Okay. You must get your fixed, which is the fixed costs, plus the variable cost. The variable cost. That is the first thing. Now, this one is equal to, in fact, even I can, yes. Kindly let me know now in the chat. I want us to go step by step. Is that one now fine? That first step? Is that first step okay? Megan, I'm waiting for your response. Okay, everyone is saying okay. Okay. Yeah, people are saying now that one is okay. Now, after, when you read through the question, they are telling us that when you look in the chart, fixed cost, they have put a Z. So it means that fixed cost is represented by Z. Plus variable cost in brackets, they have put K. So here we are going to put a K. Then for us, I want us to use capital T or to use C to represent the cost. Now let me know, is that equation okay? What I've written? We are going step by step. Is that one fine? Now that one is still fine. Okay. Now we go to the next one. Then they told us that from here, I want us now, we are going to interpret from here. From here, the variable cost according to here, we are using K. The variable cost is directly proportional. So I'll write mathematically, we say variable cost K is directly proportional. That's how we write it to the volume of the juice sold. Now we have said that our volume, we are going to represent it by V. So I will say is proportional to V. So what does it mean? It means that the K represents the costs, the costs, the variable costs, the costs, and V represents the volume. It means that more juice, when you produce more juice, the more the costs. That is the meaning. It means that the less the juice, the less the costs. Now, in order for us to remove this proportional constant, we always bring in an equal sign. So I will say K is equal to. Now, our equal sign, when we bring in an equal sign, we introduce another variable or we introduce another constant. But to remove this one here, so to remove it, we get any constant. Now, some of you are used to using K, which is okay. But here, since we have K, I don't want to mix the K's. So that's why I'm saying, can I use M? Or people are used to K? You let me know. Are we used to K or I can put any variable? I can use any variable? Okay, people are saying another variable, any, okay. Now allow me to use now M. Allow me to use MV. Then here I will say my M is the proportionality constant. Then I'll come here. Where there is K, I'm going to substitute this. So now I'll say my cost is equal to Z plus MV. Members, let me know. Are we together on that? Is that step fine now? Yes. Okay. Okay, Megan. Okay, Cassandra. Okay, good. Now we continue. Now, when we reached there, they told us that they found out that the total cost was 27,500 after 150 liters of juice were sold. Now I interpret that this cost, they are telling us that it was 27,500. But which juice was produced? The volume was 150. So I'll come and say this is Z plus M times 150. So this will give us 27,500 is equal to Z plus 150 M. This is the first equation. Kindly let me know. Are we still on the same page? Are we still on the same page? On that? People are saying, yeah. Okay, good. Now we are going to go and form the second equation. We are going to go and form the second equation. Now, in our second equation that we are going to form, in our second equation, we go, and they told us that the total cost increased to Ugandan shillings this when 250 liters of juice were sold. So our second equation, we are going to come and say 3250 will equal to Z plus 250 M. This is our second equation. Kindly, are we still on the same table? In the same, if we are together, let me know. Are we still together? Yes. Oh, Nicholas. No, yep. Yes. Okay. Yes, we are still together. Okay. Now, what do you need always to substitute? Like the cost is what is representing our C. So where there is cost is where we are putting this amount. Then volume is our V. So 250 liters is where you put your V because liters is a unit for volume. So allow me to first pick this gentleman. Lukeiriri.
Teacher?
Yes.
Teacher, I got lost from where the V came from.
The V came from here. Did you look at this? The variable cost is directly proportional to the volume. That is the statement. That's why we got V. So V stands for volume.
Teacher, could you start from there and then go to where you form the equations from?
No, did you understand this step?
No, teacher.
No, because they told us that the variable cost is directly proportional. So when they tell us directly proportional, this is the sign we use. To the volume, so I'll put V. So to remove this sign is when we introduced in an M and then a V. Now, after getting this variable cost, you come back to your original equation. Where there is K, you put that value. I don't know that we are together.
Where there is K, you use the
M.
K is direct proportion MV, yeah?
Yes.
Oh, okay, teacher.
Okay. Now, these two equations we have obtained, we are going to solve them. However, we are going to solve them. So now I'm going to come and I write them here. Allow me to use this space. I'm going to come and I say our first equation was Z plus 150K is equal to 27500. Our second equation was Z plus 250K is equal to 32500. Now, this is a pair of simultaneous equation. Now, what am I going to do? Use any approach that is easier for you. In case matrix is easy, use matrix. In case elimination is easy, use elimination. In case substitution is easy, use substitution. In case graphical is easy, use graphical. But allow me to use elimination on my side because it's going to be easier for me. Why? Because when you look at this equation, you can easily notice that Z and Z are the same. And we know very well when we are using elimination that same signs, we just subtract. So I'm going to have Z plus 150K is equal to 27500. I'll have Z plus the 250K is equal to 32500. So I'm going to subtract these two equations. So when I subtract, Z minus Z is a 0. Then here I'm going to say 150K minus 250K. So when I subtract those two, 150 minus 250, I'll end up with negative 100K. Oh, sorry, this is supposed to be M. We used M. Sorry, this was M according to our question. So this is M. Okay, can we change it? That is supposed to be M, not K. I don't know why I wrote K. Okay, that is M. Yeah. So this is M, 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 M. So here we'll get M is equal to, also subtract here, say 27500 minus 32500. So when you subtract, I'll have 27500 minus 32500. We shall end up with negative 5,000. So in order to get M, I'll divide by negative 100, divide by negative 100. So I'll have my M is equal to, divide by 100, I'll end up with a 50. I don't know whether that's what people are getting. Are we together up to that point? Very good. Hope we are still together. Yes, yeah, we are there. Okay. Now, after that point, Simon.
But sir, our teacher told us that when you are using elimination, that negative sign must be on what? Where the equal signs are this side on the right side.
It is okay. It is okay.
Okay.
For you, as long as you show that you have subtracted.
Okay.
So now, after getting our 50, go back to any equation of your choice. So say I'll have 7 plus 150M is equal to 27500. Now, where there is M, we are going to put 50. I'll have Z plus 150 times 50 is equal to 27500. So here we shall have Z plus, then you multiply 150 times 50, we shall have 7500 is equal to 27500. Then you collect like terms, you say 7 minus 7 is equal to 275 minus 7500. So here we shall have our Z equals 2. So when you do your mathematics and subtract, we shall have, I'm getting 20,000. So that is our Z. Are we still on the same page? Are we on the same page? Are we on the same page? Okay. 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 Now we are going to continue. Now we are going to go back and write our equation in a very good way, our cost. So because we say that when you come back here, we say that our cost C is equal to Z plus K, but our K was MV. So we are going to come back here and substitute and write it. So I'm going to come back and we say that our C is equal to Z plus MV. So here we shall say our cost will equal to Z, which is 20,000 plus our M, which was 50V. Now this is our equation that is relating the cost and the volume of the liters of juice being produced. Now, after doing so, I don't know, yes, Saint. Yes, Saint. Okay. Now, after getting this, I go back to the question. The question told us that part C, determine the fixed cost he incurred by the hotel on the juice. So we have already found out our fixed cost. We have already found out our equation relating the cost and the variable cost. So this is your equation relating the fixed cost and the variable cost. And our fixed cost here, we are going to just conclude and say our fixed cost was what? 20,000. So you say that the fixed cost is 20,000. But from this point, they can go on and ask you, what would be her cost if she produced 100 liters? What would be her cost if she produced this and this? So you must be able to conclude. So here we shall conclude that the fixed cost is or was shillings 20,000. But here I've said they can ask you more questions that what would be this? So this question I was testing you. Do you know how to solve simultaneous equations? Do you know how to apply your knowledge of direct proportions to situations like that? Okay, let me know in the chat whether we are fine now. Are we good to go? Let me know. Yeah. Okay. Yes. Okay. Good. Now we go to the next part. Now that number is complete. We go to the next part. Read through. I want you to first read through. Read through. So all the numbers we are going to do today are mock numbers. I just picked the first number in all the mock papers. So those are the ones we are going to do today until, yes. Okay, now when you look at the question, they're telling us that a park ranger plans to inspect 3 wildlife observation points. Point X, which is 10 kilometers north of his current location. Now, what is very important? What is important is 1, look at the number, read through it. In case the number requires you to make a sketch, please make a working sketch. Make a sketch that is working. So I'm going to come here and I interpret from here. And when you are making your sketch, please, there is no need for you to use a graph paper because you may end up wasting a lot of time. So I'll start from here. A park ranger plans to inspect 3 wildlife observation points. Point X, which is 10. Now, that is the first statement we are going to interpret. Point X, which is 10 kilometers north of his current location. Now, assuming that that person, the park ranger, I'm going to put here, I'm saying this is the park ranger here. So now they are telling us that point X, one of the points he wants to observe, is 10 kilometers in the north of where he is. Now, meaning that if he's at this point, that point is going to be like this, up. That is the north. I put the direction. So this is where we are going to have our current location, X. And I'm going to call this one 10 kilometers. Now, whenever you find directions, please do not forget to put your arrows to show the direction. Now, those are the 10 kilometers. Afterwards, I go to the next question. Point Y, which is 8 kilometers west of point X. I'll come here. Point Y, which is 8 kilometers west. Now, when you reach here, you must know the compass direction. That where is west? West is this side. So I'll move towards the west, and they told us it is 8 kilometers. So this is 8 kilometers, and this is where we have our point Y. Now I put the arrow to show the direction I'm taking. Now after that point, I'll come and point Z, which is 6 kilometers south of point Y. This is point Y, and point Z is south, about 6 kilometers. So assuming that is where the 6 kilometers. So I'll stop there, and I say this is where my point Z is, and point Z is 60 kilometers. I show the arrow. He will return to his starting point using a direct route. Now, what is the direct route? The direct route is that route that moves him from where he has ended to where he was. So that direct route will be like that. And then I would show that this is my direct route. Kindly, may I know whether we are still together up to that point? Are we still together up to that point? Yes, yes, yeah. Okay. Okay. Adikin, are we still together? Ratib, yes. Catherine, okay. Okay, good. Okay, we are together. Now, what is the question requiring us to do? One, they're asking us, how much fuel is required for the journey? Now, when you look at the journey, the way this gentleman was moving, the gentleman moved here, he came here, from here he came here, he came here, and he came here. Meaning that the total distance that this gentleman is going to cover is going to be the distance for the whole journey. And how are we going to get that distance? Now, here we need to apply our mathematics. Now, the first thing I want you to take note of, from here up to here, we have the 10, we have the 8, and we have the 6. But we don't know, what about from Z to the park? Now, this is what we are going to do. I'm going to do like this. Now, I want people to tell me, what is the distance of this green thing I have put? Put in the chat quickly. What is that distance? From the green thing, what would be its distance? Very good. It will be 8 kilometers. So here I'm going to put 8 kilometers. I'm putting another arrow to tell me. Now I'm putting here some yellow. What is the distance of that yellow part? That thing I've put here. What is the distance? Good. That one is 6. Very good. Now, can we tell what is the distance of the remaining thing here? This one I'm putting in purple. What is that distance that is remaining there? 4 kilometers. Very good. So here I'm going to put 4 kilometers. Now, after putting 4, you can notice that I can be able to find the distance from Z to the park, because now I have formed my triangle. So I can come here and I say, I have come like this, I have come like this, meaning I can find this. Here I have 8 kilometers. Here I have 4 kilometers. So, and this one is at a right angle. Can't I find this one? That this is the Z and this is the park. So here I can say the park ranger is P. So I can say that to get Z and P is the hypotenuse. So I will say ZP squared will equal to 4 squared plus 8 squared. So we are using Pythagoras theorem. So I will say ZP squared will equal to 4 squared is equal to, that is what, 16 plus 8 squared, which is 64. So I will say ZP squared will equal to 16 plus 64, which will give us an 8. So I'll get a square root, I'll get a square root. So ZP is equal to the square root of 80, which is going to be 8.944 kilometers. Meaning that our direct route is equivalent here. We have 8.944. Now, members in the chat, can you tell me, can you check out, can everyone now find what is the total distance for the whole journey? Yes, let everyone first find that one now, at least. At least find the total distance. The distance from the park to this point, this, up to when we come back. Find that distance quickly, 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 quickly. I'm going to be waiting in the chat for your answer. Very good. We are finding now the total distance. The total distance. The total distance. Daniela is saying 32.9. 32.944. Very good, people. 32. That is very good. That is very good. So here, I'm going to come. I think we're on the same page now. We're on the same page. That is very good. So I will say now the total distance covered by the ranger is going to be the 10 plus the 8 plus the 6 plus the 8.944. According to your answers, you are saying it is 32.944 kilometers. But the question told us that he will return. His vehicle consumes, from here, his vehicle consumes 0.05 liters of fuel per kilometer. But this person covered 32.944 kilometers. So can we find the fuel that he used? So here you are going to say costs of the costs of I can say the cost or the fuel required, the cost of the fuel required for the journey. So it will be the kilometers he has covered, which is 32.9944 times the amount for each kilometer per kilometer. So which answer are you getting? Which answer are you getting? How much fuel is the person using? How much fuel is the person using? How much fuel is the person using? Type in the chat, and we see. Okay, 1.6472 liters. I'll come and I say here, my answer is going to be 1.647 liters. Okay, thank you. And that is our part A. That is how we have to do our part A. So, okay. So that is what that's what we had to do. That's what we had to do. Okay. Now, we go to the next part. We go to the next part. Now, our next part, we are going to part B, Roman 1. They're asking us that convert the large-scale distribution code to the decimal system. I've told now you need to know the words. Decimal system means base 10. Now you are going to come and say, additionally, the Ranger service is distributing new GPS devices. The large-scale distribution code is 3SZC, where A represents 10 and C represents 12 in the hexadecimal system. Now, this is why I told you, you need to know the bases. Let me see whether people remember. Hexadecimal is which base? 16, very good. 16, good. Now we are going to go and convert our code. Now I'm going to come here to our code. I'm saying it's not necessary for you to construct an accurate diagram. It's not necessary. Now I'll come, our largest code we have got, our largest code they have given us is 3AZC. So what am I going to say? We are going to convert. And we say that, and remember they have told us this is base 16. So when we are converting to base 16, we say the first thing when you are converting to any base, to base system, or to the decimal place, first give them the place value, 0, 1, 2, 3. So I will say this is the same as 3 times 16 power 3 plus my A times 16 power 2 plus 7 times 16 power 1 plus C times 16 power 0. Now that is the first step. Then the next step, you are going to introduce what does A stand for, what does Z stand for. So I'll come and I say 3 times 16 power 3 plus my A. Now they told us from the question where A represents 10. So here I represent 10 times 16 power 2 plus 7 times 16 power 1 plus my C is 12. So here I'll put 12 times 16 power 0. Then I can reduce. Now, in case you don't know how to place your calc, I advise for you go on the manual way. 16 power 3 means 16 times 16 times 16 plus I love putting the brackets. Say 10 times 16 times 16 plus 7 times 16 plus here 12. Any number to power 0 is 1. So this will be 12 times 1. Now, place your calculators. Place your calculators and we get the answer. 3 times 16 times 16 times 16. I don't know what you get, but you just confirm that you get the same answer like me. That is what I'm getting according to what I'm saying. This is 2560 plus 7 times 16. This is 112 plus the 12. Now you add everything you have. You add, and see which answer you get. Which answer do you get? And according to my answer, I'm getting this. Kindly hope we are getting the same answer. Okay. Yeah. Oh, to see my Jordan, check. Jordan. Okay. Yes, we are getting the same answer. Where is 16 coming from? 16, they told us that this code here is in the hexadecimal system. And we said hexadecimal system means it is written in base 16. That is the meaning. Okay, then I will say this is my answer and I put here, this is base 10. Then I'll stop there. So that is number 2. Then we go to part C. But let me hope we are still on the same page. But I'm seeing a hand up. Let me first pick Beck and the rest, hope we are on the same page. Beck.
Yes, good morning, sir.
Yes, good morning.
I was just should we write to 3DP on Roman number 1 or to 4DP?
Yeah, I told you the best number of decimal places, they should be to at least 2 decimal places.
Oh,
yes.
Thank you.
Yeah, because if you have gone to the fuel system, those fuel things, they can read even those small points. In fact, I have not looked there, but maybe I'll check. But I know even they can go to 4 decimal places.
Oh, okay.
Okay. The hands are many. Hanis, people, let's be trying number C now. Hanis?
Teacher, but the question tells us to convert the decimal number to base 5 to determine how many GPS devices each ranger will receive.
Okay. We are continuing. Okay. We are still continuing. So they're telling us that convert the decimal number to base 5 to determine how many GPs. Okay. Now we are going to that. Now, after obtaining our base 10, we are going to convert to base 5. Now, people who have the calculators, this is where I want you to be very, very careful because we are going to use the calculators. So I'll have 14972. And I'm converting it to base what? Base 5. Now, be very careful. I want you to place your calc. We have to move together. Remember, we said this is our base, this is the number, and this is the remainder. Now, when you place your calc, say 14972 divide by 5. Now, those people who have in calculators, you are going to get an, let me be putting here, you are going to get an answer like this. What you do, you place shift, place that button having shift. Then you place A, B/C. The moment you place it, I don't know which answer you are getting. Place that thing. Hope you are getting some answer. Now, when you place it, this is the answer I expect you to get. 2994, 2 out of 5. Now, this number up here is the remainder, members. However, you should always ensure that what you have down here is equivalent to the base you are dividing with. So here, I'm going to come. Hope that one is okay. So I'll come here and I write here my remainder. Sorry. I'll come here. I say my remainder is a 2. But which answer did I get? I got 22994. I go again by 5. Place your calc. We are moving with the people who have calculators. If you don't have, I don't have any way to help you. Now we go. Place now 2994 divided by 5. So you say 2994 divided by 5. On your calculator, you are going to get 598.8. Still, place the button having AB/C. It is the third button. This is where you have shift in the same column. Shift is the first one. There is calc, then there is AB out of C. So you place shift, place that button. So when you place it, you are going to get your answer. You are going to get your answers 598, 4 out of 5. Now here your remainder is going to be 4. So I'll come here and I write my remainder. That here my remainder is 4 and I'm getting my answer as 598. Still continue by 5. So this is practical. If you don't have a calc, then place 598 divided by 5. So you say 598 divided by 5. So your answer you're going to get on your calc will be 119.6. What you do, press shift, press that button. Now, in case you place it the first time and it only gives you 598 out of 5, you place it again. Yeah? Hope you are getting it. You place it again. You place ABC. So here, you must be getting 1193 out of 5. So here, I'll come and I write that my remainder here is going to be 3. My remainder is going to be 3. And here I'm getting 119. First, let me know whether we're on the same page, members. I might be talking when we are not on the same page. Let me know whether we're on the same page. Let me know. Okay. Are we on the same page? Those who have calculators, yeah. Okay, yeah, we're on the same page. We go. Yeah, those who don't have these standard calculators, your calc may not be able to do it. Okay, now we continue. By 5. I'll say by 5. So then I place my calc again. 119 by 5. I'll get my answer as 23. So here I'll write 23 and the remainder is 4. Then I go again. 23 by 5. I'll get my answer as 4, remainder 3. Now, the moment I reach a number that is less than the base I'm dividing with, I'll stop at that point. So now this is where we are going to stop because 4 is already. But I want you, please do not cram. Whenever you are using this approach, what do you need to remember is should you get a number, let me say 119, and this is 2 out of maybe 3. And the base you have been dividing with is, let me say, is 5 or something like that. You first make sure that the base down matches with what you have. You make sure that it matches with what you have before you continue. Okay. Okay, now here I'm going to come and I make my conclusion. We said we always take the reverse order. So since they wanted us to convert to base 5 to determine how many devices each range will receive, then I'll come and I say this is 4, 3, 4, 3, 4, 2. And this is going to be to base 5. So that's how you do it. Yes, Trevor.
Good morning, sir. Like my culture is very different. It's these programmable ones. So
Okay.
like for me, like that place for A, B, and C, for it just like has this these fraction things, but they are empty ones.
Does it bring the same thing?
No, I don't have it has refused. It doesn't do so. It
Are you
only
saying where you
has
have SD on that calc?
SD, yes.
Place that one.
Oh, are you pressing SD?
Mm.
Okay, thank you, sir. Let me try and see.
Okay.
Let me get 99119. Then I divide by 5. Then I got after pressing SD, I got 23.8.
23 points? Place that SSD,
8.
what do you get?
The what?
When you place that, it has something like S, then it has something like this, something like this.
Yeah. Oh, I've seen it up. Yeah, I've seen the fraction parts up. Like I think I should press shift. Yeah, I've got it. I've got it. Thank you, sir.
Okay. Lastly, Priscilla.
Yeah, I've seen.
Now we have finished part B. Members, let's be trying part C. Priscilla. Priscilla. Oh, Priscilla, I'm not getting you. Oh. Queen Esther.
Okay,
Queen
teacher, I
Esther.
just want to confirm. So this number that we got of 434342 base 5, are they the number of GPS devices?
Yes.
Okay, thank you.
Okay. Then lastly, Gloria Namudu.
Good morning, ma'am.
Good morning.
For me, I have used AB stroke C. So I say 2 3, then I placed AB stroke C button.
Okay.
So
Does
I
it
got
work?
the answer.
Okay.
Yes, it
That
works.
is, which kind of calc do you have? You need to tell people.
It is
This
on the phone.
Oh, you have pressed on a
No.
phone. Okay, that is very
Yes.
good. Okay, but hope, Gloria,
Okay,
you have
thank
a
you.
calc.
Yes, I have it.
Okay, okay, good.
Thank you.
Okay, okay. Let's first, the rest, let me hope you are trying as I pick these hands. We are trying part C. Yes, Matthias, Amal, and Ismail.
Morning, sir.
Good morning.
They'll say that it's in base 5. You have to put it in base 5.
Yes.
And you use the other method, whereby if I try to, this one you're using, if I try to press 14972, I divide it by 5. I get this very answer, but 0.4. Cut, what if I write that for there? I think 4 is in base 5.
No, 0.4. 0.4 is not, remember we are writing only the remainder. So you must write the remainder.
Okay.
So 0.4, you place the calc such that you get to know what is the remainder.
All right. Understood.
Okay. Okay. Amal, the rest?
Yes, teacher, we are done with the application.
Oh, you are done with part C, eh?
How we make up?
Okay. Okay. Which answer do you have? Those who have finished, I want to see the answers we have.
We are supposed to use LCM.
Oh, same. Okay.
Yes.
Oh,
And then
I've seen some question here. Someone was saying, what if they tell you to put it on an abacus? Yes, when they tell you to put it on an abacus, you just say, here, you have 2, here you'll have 4, here you'll have 3, here you'll have 4, here you'll have 3, here you'll have 4. Then you put your balls. 1, 2, 1, 2, 3, 4. Then here you put, this is ones. When we are in base 5, we say 5s. Then you say 5 5s, 5 5 5s, 5 5 5 5 5s, 5 5 5, like that. In case they tell you to put it on an abacus. Okay, now when you look at the last part, they told that 2 Ranger patrol teams operate on different schedules. I told you when it comes to scheduling, the first team patrols a nature reserve every 25 minutes, and the second team every after 40 minutes, starting from 10 p.m. Determine the time before midnight when both teams will meet at the reserve. Yes, what does it mean? Here it required the moment you see when they will meet again, that is an idea of LCM. So now that means I'll expect you to come and I say you have 40 and 25. Now, I want you to pay attention. I have ever seen a question whereby they gave you 40 minutes. They say the first team operates after 25 minutes, another team after 1 hour. So here you have 25 minutes and here you have 1 hour, meaning that you cannot use your LCM directly, meaning you first convert the hours to what? To minutes. And always when you find that they are in hours, in order for you to get those LCM things or HCF, please always first convert them to minutes, and then afterwards, after getting your final answer, convert them back to hours. Hope you have taken note of that. Don't work in hours unless all of them are in hours, but work in minutes. When you find that they are different units, convert them to the same units. And always I want to let you know, it is always very hard for you to deal with, to find the LCM when you have points. Take an example that you have 1.5 and you are finding the LCM. It's going to be hard for you. So that's why I'm saying convert them to the minutes as one of the lowest measurements of time. So here, allow me to start with 5. I say by 5, I'll get 5. I'll get 8. By 5, I'll get 1. I'll get 8. And by 8, 1, 1. Meaning that my LCM is going to be 5 times 5 times 8. And here, I'll get my 200 minutes. Now, after getting your 200 minutes, this is when you can go back and then convert them to hours. So 200 minutes, how many hours are those? Let me see in the chat. How many? I want to see how many. Thank you, Megan. I was saying that. Okay. Okay, 3 hours, 20 minutes. Very good. So here it's going to be 3 hours and then 20 minutes. Then you ask yourself, they started at 10 p.m. So then that means you're going to say 10 p.m. plus your 3 hours and 20 minutes. So which time are we going to get when you add, when they are going to meet again? Which time are you going to get? Now here we are testing. Do we know how to add? What time are we going to get? 120, 120, 120. Yes. So people are saying here we shall get 1:20 a.m. Now, your conclusion is very key. I told you that when you're concluding, make a decision and then put the reason. Now, let me see. Who is concluding for us this number? They told you at what time before midnight will they meet again? Ismail, are you giving us an answer? I want someone who is going to conclude. People, Ismail, unmute. Who's concluding? Someone to give us a conclusion. I don't know whether Megan, you can give us that conclusion you wrote in the chat. I want someone to give us how you feel you are going to conclude. Joan, 10 p.m. plus 3 hours, we get a.m. I think, what do people think? Isn't it a.m.? p.m. is midnight. Okay. Yes. Fogo, is it p.m. a.m.? It is supposed to be p.m. a.m. a.m. Okay. Okay. Yes, Vincent, conclude for us.
Thank you, sir. For now, conclude by saying they will not meet before midnight because they will meet at 1:20 a.m., which is 1 hour, 20 minutes past midnight.
Very good. Very good. That is correct. Shina?
They will not meet before midnight because the teams will meet after midnight.
Okay, good. Now, Shina, your conclusion, you are missing putting the figures.
Okay, yeah. Thank you.
Okay. Gloria?
They will meet again after 1 hour and 20 minutes in the morning.
Now, there's a word that has that you have missed because they cannot meet again.
Yes.
Okay. Okay. Vincent. Okay. Sally Sunday. Yes, Sally Sunday, I've said, when they give you in hours, let it have it in what? In minutes, for easy calculation. Because they can tell you 3 hours and 2 minutes. Then you cannot work with such. Fugo?
My conclusion would be the two teams would meet. No? Both teams will meet again at the reserve at 1:20 a.m. after midnight.
Okay, good. Yes. So, yes. Yes, Joan, 13:20 is in the 24-hour clock, eh? That is 24-hour clock. No, Joan, 13. Okay. Now, now that is the conclusion. So in your conclusion here, I'll expect you to first make a decision. Your decision is going to be, they are not going to be able to meet before midnight. What are you basically going to say so? Because the people or the ranger people, they can only meet again after 3 hours and 20 minutes, which will happen at 1:20 a.m. First put that negation that they cannot meet. They will not be able to meet before midnight. Then give your reason. Because these people can only meet again after 3 hours and 20 minutes. Or they can only meet after 1 hour and 20 minutes after midnight. Something like that. So that would be a good conclusion. But now Joan is still insisting. I think Joan, this is our clock. I think here is where you have 1, here you have 2. Hope it is like that. 3, 4, 5, 6, 7, 8, 9. This is 10. This is 11. And this is 12. Now, Joan, what you need to know that from here, anything this side here is what we call AM. Anything this side is what you call PM. So from 12, 1, 2, 3, 4, 5, 6, because they last met at this point here, which was 10, it was in the evening. So after 3 hours, you count, this is 1 hour, 10 to 11 is 1 hour, 11 to 12 is another hour, then they entered a new day, which is going to be 1. So your 1 is the equivalent of 13, because if you are counting in 12 hours, this is 12, this is 13, this is 14, 15, 16, 17, 18. So that's why we are saying that they will meet, this is going to be AM, because everything this side from 12 to 6 is always AM. This side, you always have PM. In other words, those night things you are seeing up to like midday, those are the AM things up to before midday. Yeah. So you need to take note of that. Hope, Joan, we are together. Joan, let me know in the chat whether we are together. Okay. Okay. Okay, now we have finished this number. Now we can go on to one more number. I have about 5, 6 numbers, but let us continue and see how far we can go. Okay, read through. Read through as I pick Sheena. Sheena?
Yes, teacher.
Yes.
So what do we use the greatest common factor?
Oh, we have said we use it when we are doing splitting, dividing things. Let me say, they may tell you 2 tailors, they have got orders, they want to maybe to see the size of the cloth, what. Those things that involves things of dividing is where we use HCF.
Okay, thank you.
Even when it comes to building, you want to find out the size of the tile to put in your room, those ones. In case you are preparing a party, you want to find out how many people you should invite for the party. Maybe you have budgeted that on your birthday party, I'll have maybe queen cakes, I'll have sodas, I'll have this, and then you want to find out how many friends you should invite. Then you need to know that on my party, these are the people I can invite. So in order for you to find out the number, how many people, such that what you have bought, you can share it equally, is when we use HCF. Okay. 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 We hope people are reading through as I pick Okanya. Okanya? Okanya, unmute. Okanya, unmute. Oh, Okanya is not unmuting. Agupale Ratib.
Yes, thank you.
Yes.
The question reads, your friend is a market vendor. She realizes that her customers prefer buying tomatoes in small quantities. So she decided to repackage her tomatoes into heaps of 4. One day, she bought 9 heaps of tomatoes, which had 8 heaps which had tomatoes each from which had 8 heaps of 4. One day she bought 9 heaps of tomatoes, which had 8 tomatoes each from the market at a cost of UGX 2,000 per heap and was given a discount of 5%. She decided to sell her heaps of 4 tomatoes at UGX 12,000 each and hence wants to find out how much gross profit she will earn from all her heaps. She further intends to visit Queen Elizabeth National Park in December 2024. Her uncle visited the same tourism center last December 2023 with his 3 children and spent UGX 17,000 on entrance ticket. Mr. and Mrs. Mukasa visited the same park in June 2024 with their children and spent UGX 14,000. She plans to buy entrance ticket for herself, husband, and 5 children, and hence needs to know how much she will need.
Okay.
If park changes are adjusted after 5 years, task. How much? Please scroll a bit.
Scroll.
Yes, scroll it up a bit.
It is to full screen. Okay, but it is okay.
Yeah.
Thank you so much, Ratib. Now, when you are interpreting the scenario questions, first read it the first time. Read it again. Read it again. Then start interpreting step by step. Don't rush because you have seen this and this. Don't rush. Now, one, I told you, still this is about number bases. There is an idea. In this same topic, there is an idea of discount, which is business math. Still in the same topic, there is something about percentages. You need to remember what we call percentage decrease. Then you are noticing, we are going to notice that also there are some equations that we need to work on. Now we are going to go and first interpret slowly, step by step. So they told us that your friend is a market vendor. She realizes that her customers prefer buying tomatoes in small quantities. So she decides to repackage her tomatoes into heaps of 4. Now I have told you already at the beginning, when they talk about heaps we are referring to groups. And I told you when they say heaps of 4, it means that is base 4. That means heaps of 4 or groups of 4. It means that she's putting 1, 2, 3, 4 tomatoes in each kavera. 1, 2, 3, 4 in each kavera. Then they told us that one day she bought 9 heaps of tomatoes, which had 8 tomatoes each from the market. Now that is the first statement we are going to interpret. Why? You are going to find out. Now I'm going to first say total number of tomatoes bought from the market. Not so? They are telling us that he bought 9 heaps. 9 heaps means 9 times. In each heap, it had 8 tomatoes, then times 8. And here I will say 9 times 8 is equal to 72 tomatoes. Is that first step fine? I don't want us. Is that first step fine? Let me know whether we are okay on that first step. Yes, fine. Fine. Okay, yeah, it is. Now, those were the total number of tomatoes. Like those people, like an heap, you know, an heap. Like when you go to those ladies selling, you'll find something like this. 1, 2, 3, 4, 5, 6, 7, 8, 8. Now, this was one heap. 1, 2, 3, 4, 5, 6, 7, 8. This is the second heap. 1, 2, 3, 4, 5, 6, 7, 8. Now, he bought these heaps, which had 8 tomatoes in each heap, but they were 9. So to find out the number, so you say this 8 plus this 8 plus this 8 plus up to when you complete all the 9 heaps. So in simple terms, that is like getting the heaps, which are 9 heaps times the number of tomatoes in each heap. That is what we are saying. So that means that the total number of tomatoes altogether, they were 72. But remember, her target or what she wants, her goal is to repackage. Then we go. Then we say each from the market at a cost. One day she bought the 9 tomatoes, each from at a cost of 2,000 per heap, and was given a discount of 5%. Now, you are going to first find out what is the cost of buying. I'm going to say cost of buying. How much, what did she incur in buying? So you'll come and say that each heap, there were 9 heaps, but each heap was at 2,000. So how much is this? 9 times 2, this is what? 18,000. But they are telling you, this is shillings, but they are telling you that, and was given a discount, meaning that this person who was selling, she told, like when you go to the shop, you can say that, you know what? Maybe Priscilla, you know what? I'm selling each heap at 2,000. But if you buy more, if you buy many, I'll remove for you some discount. So now this person was given a discount of 5%, meaning that if this was the price of the tomatoes, before the discount, but now when she was given discount, we are going to find out how much did she buy now the tomatoes. Hope we are together on that. Then now we are going to say discount. Now here we have 2 ways of doing the discount. Now the discount is 5%. So what are you going to do? You can say 5 out of 100 times 18,000. So here, when you place your calc, you'll get 900 shillings. So how much did she buy? Now here I'm going to say the actual expenditure on the tomatoes. So actual expenditure is going to be the 18,000 she was meant minus the amount of money they reduced for her. And this one is giving us 17100. So that means that her actual expenditure on the tomatoes was this. But remember here in the question, they're using UGX. Please, I told you yesterday, we stick to UGX. Allow me also to remove this and I replace it with UGX. So here we shall have UGX. Here we are going to have UGX. Kindly let me know. Are we together on that step? Are we together on that step? Let me know. Are we together? Yeah, we are still together. Very good. Alternatively, people who don't want to use this approach, for you would have said the second approach, you would have said when you want to get the actual expenditure, you can also say that the actual expenditure is equal to 95% of the 18,000. So that means you'll be able to get 17100. So this is the second approach that you can use. So you can either use this to first find out how much money they reduced for her, and then you get the actual. Then we continue. She decides to sell her heap of 4 tomatoes at Uganda shillings 1200 each. Now you're going to first find out if altogether she had 70 tomatoes. If she's making heaps of 4, how many heaps is she going to get? Let me see through the chart. She has 72 tomatoes, but now for her, she wants to put them in heaps of 4. How many are we going to get in total? How many heaps? 18 heaps, 18 heaps, 18 heaps. Very good. Now I'm going to come here and I say heaps are number of heaps of the 4 tomatoes. Now I'm going to say our total number was 72. I will say 72 divided by 4. So here I'm going to get 18 heaps. Hope we are still together. Now, after getting the 18 tips, you ask yourself, how much is she going to earn from the 18 tips? Yes, how much? How much after selling the 18 hips? How much? So amount for selling the 18 hips. For selling 18 hips. So that means we are going to come and I say it's going to be 18 times. How much is she selling? She's selling her hip at 1200. So here I will say 1200. So how much am I going to get? This is UGX. It's going to be 21600. Members, are we still together? Members, are we still together? Are we still together? Prince, unmute.
Good morning, sir.
Yes, good morning.
We have here at the actual expenditure, we're having one additional 0.
Oh, 17. Which addition 0?
The
Oh.
additional 0. Yeah.
Oh, okay, okay. Let me remove here.
Yeah, here and there.
Okay, okay. Thank you, thank you. Okay, okay. Thank you. Let me hope we are together on that. Very good. Now, we are going to find out. They asked us, how much gross profits will she earn from her hips after repackaging? Now, what are you going to do? What are you going to, can't we find that, members? Find it. That she has sold her things, she got this. Then how much expenditure did she incur? It is this. Can everyone find that and we see how much is that? How much? Nadine, what are you getting? Find. Joseph, what are you getting? I want to see how people are finding, getting the actual one. Some Shina is saying 4-5. Nobody is saying 4-5. Others 4-5. 4-5. 4-5. Okay, good. Now we are going to come. Allow me to write here. So I will come and I say my gross profit. My gross profit is going to be the amount, or what we are going to call the selling price minus the cost price. So here I will say, or here you can say the amount of money she sold the 18 tips minus the actual expenditure. So here we have 21600 minus 17100. So people have said they are getting 4500. So here it will be UGX 4500. And therefore here you'll conclude and say that she will earn a profit of 4500 after repackaging her hips. And this is what the people, those ladies you see in the market, they do. Yeah, they go, they buy a sack of those banana fingers. After buying a full sack of the banana fingers, they get it and they start now putting it in small packages. And for you go there and you buy one for 1,000, for 2,000, like that. So they keep on making a lot of money from one sack of what they have come. Yes, Jonathan.
Good morning, sir.
Morning.
My question is,
what is the difference between profit and gross profit?
Okay, now for this scenario, it is the same. Gross means like the total profit. In other words, gross, the overall profit.
Okay.
The overall profit that you get. Yes, Queen Esther?
Okay, teacher, at the beginning you had said that the number is about bases. So I was wondering where the bases were applied.
Here, one, how do we call heaps? When they talk about heaps, what comes to your mind?
Groups.
Groups. And when we talk about groups in math, it means?
Bases.
So that's where the bases are.
Okay, teacher.
Yeah. So they are showing you the real life application. So when you find those ladies selling things in Nakasero or in those markets, putting them in small heaps, they are applying number bases. And for someone who knows very well number bases, even for you, even you can say that, even here now, the question even can come and they ask you, if this lady wanted to make more profits, what would she have done? Then you need to know, if I may be increased on the group, on the number of items in each group, and then I increase the price, I would have made more profit. Then the last one is Mason. You are the last one.
So mine is just clarity. You had said that when they talk about heaps of 4, they mean base 4. And usually base 4 does not have 4 in it. It stops at 3. So how exactly is heaps of 4 in base 4? Isn't it like base 5?
Oh, no. Now, I told you that when it comes to grouping, when they talk about groups of 4, it means that they are grouping items in 4s. That is the meaning of base 4. That when you are packaging, you only put 4 items in it. Are you getting it?
No, I don't get it, because base 4 does not have 4 in it. But then
okay, now what? Okay, what you are talking about, we call them numerals. But here we are finding how many groups are they of 4. How many groups have you been able to form of 4 items? Are you getting it?
Yes.
Yeah. Now, like when you look at groups, let me say, when I talk about, let me use 10. Let me use 9. When I talk about groups of 9, it means that in my basket, I'm going to put only 9 items in it. These are 6, 7, 8, 9. I'll put only 9 items in each basket. That is the meaning of base 9. So meaning that the items shouldn't exceed 9. 9 should be the maximum.
But then that would also mean 9 is a value.
Which one?
Doesn't it also mean 9 is a value and you cannot have 9 base 9?
Oh, no, now here, now, okay, I get. Now, like, you are confusing the numerals we have in those groups. Here, we are not looking at numerals. So I don't want you to look at the numerals we have within the base. Here, we are looking to how many groups have you been able to form of that given base you are working with.
Oh, okay, I get it.
Yeah.
Thank you.
Okay. Let's now continue. Okay, now, what happened? Okay, now we go to the next part. Now the next part is part B. How much money will she spend in total to buy the tickets she wants? Now you come, interpret sentence by sentence. Then we come from here. So we have stopped. She further intends to visit Queen Elizabeth National Park in December 2024. Her uncle visited the same tourism center last December with his 3 children and spent this on entrance ticket. Mr. and Mrs. Mukasa visited the same park in June with their child and spent this. She plans to buy entrance tickets for herself, husband, and 5 children, and hence needs to know how much she will need. If park charges are adjusted after 5 years, then go to the question. The money will she spend in total? Now, when you look at this scenario or this scenario item, you are noticing that there are 2 things that are changing for each statement. That we have the adult people and we have the are the children. Now, I want you always to apply to real life. Whenever you go to those places, or for many of those events, always we have the adults and the children pay different prices for the entrance. You find that an adult is paying maybe 5,000, a child will pay 3,000. So when you are looking at these statements, you are noticing that the first family, they went as the family and they had the children. The second, they went with the family and the children, meaning that the two things that are varying in the statement is the adult people and the children. So the first thing you are going to relate here, you are going to say, now I have two things that are relating. So I'm going to come and I say, for this, what's happening? So I'm going to come and say that, let the adults be represented by A. Let the children be represented by C. That is the first step. Then you are going to go back and ask the first family that you visited. They told that her uncle visited the same tourist center last December 2023 with his 3 children and spent this. Now, when you look at her uncle, that means that was one person, an adult. So I will form that equation. An uncle who is an adult, one person, plus the 3, if you want, you can say one adult person plus how many children? There were 3, so I say 3 children. And what am I getting? That these people are spent 17,000. That is the first equation. Then you go, Mr. and Mrs. Mukasa. Now, this is where you need to understand. Mr. and Mrs. Mukasa, how many adult people are those ones? Let me see whether we are quick at how many people are those? Mr. and Mrs. Mukasa. Very good. 2. Very good. So here we shall say 2 adult people, A, plus the children visited the same park in June with their child. With their child, meaning that the child was one child. And they spent 14,000. Now, after that, you continue and you say, with their child and spent this. She plans to buy entrance tickets for herself, husband, and 5 children. Now, what are you going to say? Here, when I'm letting, since the interest is knowing the tickets, I'll say, let the adult ticket be represented. In fact, I put, let the adult ticket be represented by A. Let the children ticket be represented by C. Because we are interested in knowing how much do the children pay and how much do the adults pay. Yes, Mike, can we start? Yes, Mike. Mike? Okay.
Yes. Now, for me, what I was saying, my question was, I was saying that in these numbers, in these scenarios that they bring, am I allowed to apply? For example, you can see a scenario when it has like 5 to 4 topics in it. Now in part A, I can use the knowledge from number bases. Then you find number 2, part B, it's for linear programming. Am I allowed to use different knowledges, or I should stick on one topic?
No, use different knowledge, because like I've told you earlier on at the start, that this topic, they combine different topics. Now, I come back here. Now, I'm putting this one as a coefficient, but it is not necessary. So, if you have understood, there's no need for you to put the what? The 1. So, here you need to know very many topics. So, I don't know whether you can allow me today for this particular number to use substitution method. Allow me now to apply substitution. So, when I look in the first equation, I'll say my A plus 3C is equal to 17,000. Always use the N. So here I'll have say A is equal to 17,000 minus 3C. Now, after obtaining this, I'll go and I substitute it in this equation. So I'll set to where there is A, I put 17,000 minus that one. So I say 17,000 minus 3C plus C is equal to 14,000. Now, what am I going to have? Now, when I reach at this point here, I'm going to come and I open the brackets. So I'll say 2 times 17,000 minus 2 times 3C plus C is equal to 14,000. So now I multiply 2 times 17,000. I'll have, this is 34,000 minus 6C plus C is equal to 14,000. Now, when I reach at that point, I'll negative 6C plus C, that is negative 5C. So here, I'll have 34,000 minus 5C is equal to 14,000. Then I make this one cross the other side. So I have 5C is equal to 14,000 minus 34,000. So negative 5C will equal to, when I get 14,000 minus the 34,000, I'll get negative 20,000. Then I divide by negative 5, divide by negative 5. So I'm not think that my C is equal to 20 by 5. I'm getting 4,000. So I'll say that my C is this. Then I go on and now I calculate for A. So I've already said that my A is 17,000 minus 3C. So I'll say my A is equal to 17,000 minus 3C. So this will be 17,000 minus 3 times now my C. My C, I've already obtained 4,000. So this will be 17,000 minus, this is going to be 12,000. So 17 minus 12,000, you end up with 5,000. And therefore, now I'll conclude, I say my A is equivalent to Ugandan shillings 5,000. My ZC is equal to UGX 4,000. Then I go back to the question whereby they told us that this person is planning, she plans to buy entrance tickets for herself, husband, and 5 children. So you are going to say, now, adults, I'm going to say, how much does she need? So I'll say the total costs. Cost needed for it, or I'll just say costs. So now to get the total costs, it means we have 2 people, 2 adult people, and each of them is paying 5,000. Plus, we have how many children? I think there were 5, and each child is paying 4,000. So here I will say 2 times 5, which is 10,000, plus 5 times 4, which is 20,000. So that means that in total, this person will need Uganda shillings. This is going to be 30,000. So then I will conclude and say that the money she needs to buy the tickets is shillings 30,000. But also when you are working out these numbers, always make sure you reason. You check out that adult, I have got 5, child, I've got 4. So it makes sense because that is within the given range. Okay. But here, when you are solving, use any method that is really very good for you. Any method you find easier. In case this matrix, use that. Graphical, use that. Any method, as long as you budget for your time very well. Yes. So as long as you budget your thing very well. Okay. So I think that is okay. I can now take on one hand. Yes, way too high. Way too high. Way too high.
Monster.
Yes.
For me, I was supplementing on the one who asked you about answering an answer format. Once at school, they told us that when you're answering, you're supposed to answer according to the elements of construct. Now you see like number 2 is about patterns and algebras. So that construct, you find that they can put a number where you can apply the knowledge of proportions. But unfortunately, when they're solving, they don't square proportions. You're supposed to apply the knowledge of equation of a straight line. Yeah, that's it, sir.
Okay, thank you so much. Yes, so those elements of construct will help you or will guide you whenever you are reading. Yes, Agupale, Ratib.
Yeah, thank you. Now, how do you conclude here?
I have concluded. I've told you that here your conclusion you will say that she will need to budget for 30,000 shillings to buy the tickets for the family.
I thought that statement that is talking about the adjustment should maybe apply.
Oh, okay. Let me talk about it. Now, this statement is to indicate for you that these people, when you look at these people here, we have the first person visited in 2023, another one is visited in 2024. And it says that the park charges are adjusted every after 5 years. Now it shows you that the prices are constant. The prices are not changing up to when the 5 years have elapsed. So this is 2023, this is 2024, 2025, 2026, 2027. So it was an indicator to show you that the prices at which they found are still the same prices, that they can only be adjusted when 5 years have passed.
Okay, thank you.
So that was the meaning of that statement. Yes, Regan. Okay. Okay. We continue. Now that one is finished. Read through that. But I have about 10 minutes. Let's read through quickly. This is Kigez mock. Read through. And like I told you, you'll find ratios and proportions in many of the papers. Regan.
Thank you, sir, for the opportunity. I'd like to inquire from you where you substituted from. Is it a must to substitute the equation we get the value of A in the second equation, or we can still use the first one?
You can use any. You use any you want.
Oh, thank you.
Okay. We are going to continue. Okay. Now, when you look at this particular number, you are not seeing we are not seeing that for this particular number, one, you are going to first come up with your simple sketch. So may I ask you now, everyone, to first come up with a simple sketch. Whenever you find that it requires, please make that sketch. They will score you for the sketch you have drawn. So you make that sketch, everyone. That is the first thing. After making the sketch, I want you to go on and find the kilometers you are going to be traveling. After that, go on and find the fuel. I want to start from there, but I want everyone to first try. Yes, Comfort. Now, Comfort, your question. For that particular question, still you use the you use inverse. You can use inverse. Yeah, but I'm going to talk about it. Yes, but as people are trying, So comfort, to help you on that particular number, you have 3 variables, or you have 3 things that change. You have, I don't know the comfort, you can unmute. Comfort, where is comfort? Comfort, unmute. Comfort, unmute. Oh, okay. Comfort is failing to unmute. Yeah, but let me talk about, she's asking, how do you attempt when they have given you men, they have given you days, and they have given you land, and they ask you to find the number of days. Now here you need to know is that men, days, and work. You know that when you have more people, more men, it means that more work is going to be done. However, when you have more people at work, it means that less days are going to be taken. So here you write your equation that more men means more work is going to be done. However, the number of days are going to be less. So mathematically, this is how we write it. So you say men will equal to the K W out of D. Then after you substitute. Now, like for this particular question, you said that there are 3 men. So where there is men, you put 3 is equal to K times the piece of work, which is 4, out of the number of days, which is 7. So you end up with 21 is equal to 4K. Then you divide by 4, your K will equal to 21 out of 4. After getting K, you come on and substitute it in your original equation. So you get men will equal to 21W out of 4D. Now, when they ask you, now like they asked you that 7 men, 6 piece. Now men, there were 7, and piece of work they had was 4, I think it is 6. So out of the 4D. So you do your mathematics here quickly, and then after you find out what your D is. So that is how you do it. Yeah. So you find out and you get the answer. So that is the approach you use. Hope you have been able to get that. So you need to reason in that format. More work, more men means that they'll be able to do more. But that is an assumption. Eh? Otherwise, at times you may have more people and they do rubbish. You may have more people and they do rubbish. Okay, I think people have tried. And now I am going to start. Okay, now the first thing always you do, make your simple sketch. At exactly 8, we must be ending such that I can run in for an activity. So they are telling us that John plans to visit the shop that is 12 kilometers south of his home. Now you need to know that if this is the home where the person is, they're telling you that is 12 kilometers south of his home, meaning that I'm going to move in the south like that. And those distance is 12 kilometers. And then the boutique, this is where now the shop is. And then the boutique is 5 kilometers east. Then travel very well. East is this side. So this is where we have our boutique to home. Then how many kilometers? They told you they are 5 kilometers. He is to use a motorcycle that consumes 0.035 liters of fuel per kilometer. And he wants to know how much fuel he will need for the whole journey. For the whole journey means he's going to go to the shop, he goes to the boutique. But here, since you need to know that if he's for the whole journey, meaning that he has to go back where? At home. So now that is the direct journey. So this is the direct journey. So now the first thing you need to know that when the south and the east meet, they meet at night. So you are going to first find the distance from home to the boutique. So the distance, I can say, distance from boutique to home is going to be the square root of 12 squared plus 5 squared. So this will be 144 plus this is what, 25, which will give you 169, and it will give us 13 kilometers. So here the distance we shall have is 13 kilometers. Now the total distance covered. So I will set the total distance will equal to, now you add 12 plus 5 plus 13. So I'll say 12 plus 5 plus 13, and I'll end up with the This is what, 30? What are you getting? 30, I think. So this will give you 30 kilometers. Then now you find how much fuel. Then I will say fuel needed. Fuel needed or fuel to be used will equal to the 30 kilometers times the fuel consumed per kilometers, which is 0.035. So when you make 30 times 0.035, you end up with 1.05. And these are how much fuel will be needed, and these are going to be liters. I think in the question, I don't know what is the right spelling for liters, but they are going to be liters. So that is how you do it. I'm happy people had gotten that's the particular answer. Okay. Are we good to continue, members? Let me know in the chat. Are we good to continue? 1.075 liters. Okay. Now, after that, yes, Shina?
Teacher, I thought while dealing with this sketch number, you first change it to centimeters.
No, a sketch.
The recent meters, then 13 kilometers.
Okay, not really. You only do that if you are going to make an accurate diagram.
Okay.
When you are going to make an accurate diagram, you can put them in centimeters. But for a sketch, leave it in kilometers. Okay. Okay. Now we go to the next part. He has 750,000. Now, this is the first topic. Now, when you look at the second one, this is where I was telling you, we bring working with integers, knowing how to convert from words to figures. So they are telling us that he has 750,000. Now you first write the amount he has. Amount John has. Now, that one, if you don't know, that's where you're going to go off. So this is UGX, and they're using capital. I will stick to the capital again. So I will say UGX is how much? Is 750,000. He plans to use part in the shop and part in the boutique. Now you come and write shop and the boutique. But which ratio have they given us? They've given us in the ratio of 3:2. He wants to spend this to buy shirts and this to buy trousers. So now here we have two things. We have that this person is going to visit the boutique and this person is going to visit the shop. When it comes to the boutique is buying shirts and the shirt is UGX to this shirt is very expensive. I don't know that they exist. And trouser, do they exist? Can someone let me know in the chat? A shirt, she wants to spend this to buy shirts. Oh, there are many shirts. Okay. I was wondering whether it was one shirt, but there are many. And this one on trousers. However, he's not sure if the budget for the boutique will be enough. From the shop, he is to buy packets of cooking oil. Then I will come, cooking oil. Cooking oil is 24 packets. Allow me to use that one. Sugar is 12 packets. And then salt is 30 packets. All of these are to be used. Take note, all of these are to be used, meaning that nothing should be left for some of his family members in the village. Now, what does that statement mean? It means that there is some kind of distribution that is going to do. And if everything is to be used, that means that you must not remain with any remainder. He wants to each package to have an equal number of items. I told you earlier on, the moment you see things of packaging, distributing, you need to know that there is something I'm going to find out. He needs to know the highest number of packages he can make. Now we have finished part A. Now, will the money he plans to use in the boutique be enough for what he plans to buy? Justify your answer. Now, already we have the ratio, which is 3:2. So I will come here and I say total ratio total ratio is going to be 3 plus 2, which is equal to 5. And please show, some of you may come and say, total ratio is 5. How have you gotten 5? Then I'm going to say, money allocated for the boutique. Allocated for the boutique. So here the boutique is taking 2 parts of the 5 parts. So I'll say it's going to be 2 out of the 5. But how much does he have? He has 750,000. Then you do your mathematics. And when you look here, you are noticing that the shillings he has 300,000. Now, you ask yourself, but what is the price? What is the total amount he's going to spend in the boutique? Then I'll come, what is the total amount to be spent? Amount to be spent in the boutique. So when you check well for the shirts, it will incur this plus the 120 for the trouser. So here we shall have UGX. This is what? 330,000. Now, that is for part B, but we have not justified the answer. Can now someone put a hand up and you tell us, can someone put up the hand and then they tell us how we are going to conclude? I want now a conclusion. Someone to raise up the hand. Way too high, are you giving us a conclusion? MG, are you giving us a conclusion? Any of you? Yes.
Yes, I'm getting a conclusion, sir.
Okay.
My conclusion is. Hello?
Yes, continue.
The money he plans to use the boutique is not enough, hence it being 330,000.
Okay, that is one way. Thank you. Yes, there is a decision and he has put a figure. Way too high?
Yes.
Okay. My conclusion is like the money he plans to use in the boutique won't be enough, because the total money he's to spend exceeds by 30,000.
Okay, very good. That is a good conclusion. Ratib?
Okay. His money for boutique is not enough. He needs to add 30,000 to achieve his plan.
Very good. Yes. Zoom and Pal?
So for me, what I'm saying would be the total amount of money to be spent exceeds the money allocated to the boutique.
Okay. Yeah. Do not forget now to put your decision. So your decision tells us whether it is a no or a yes, and then you justify with a reason why you are saying so. Okay. Now we are going to continue. Now that is for part B. So you'll say, will the money he plans to use in the boutique be enough for what he plans to buy? Then you say, no. The money he's planning to use in the boutique will not be enough or will not fit within his plan, because the money he needs is 330,000, which is more than the amount of money that has been allocated for the boutique by 30,000. Okay, now we go to the last part. Now they're asking us, how many packages will he make from the items he plans to buy? Now, when you look at this number, look out for the conditions that were given in the question. They told that all these are to be used to make packages. Everything must be used. Number 2, they told that they must know the highest number. He needs to know the highest number of packages he can make from them. He wants each package to have an equal number of items. Let me say through the chat, what are we finding? Our people have already put the answer. Very good. We are looking for the highest common factor. Very good. Very good. Yes. Very good. Yes. Let me hope we are still together. Yes. Yes. Comfort, I answered your question. I answered your question. Unless maybe you dropped off. Now I'm going to come here and I say now my part C. We are going to look out for the HCF of 24, the packages, 12, and then the 30. And I want you to check always, are they in the same units? All of them, you notice that they were packets. So the units were the same, meaning we can go on. Now I'll start by 2. Here I'll have 12. I'll have 6. Here I'll have 15. I ask myself, is there another number? So 2 goes through all of them simultaneously. By 3, what do I have? I have 4, I have 2, I have 5. Then I ask, is there any other number that can go through all of them at a go? I think there is none. Where to high? You have a question?
No, sir.
Oh, okay. Do you want a question?
Teacher, you said we are able to do the HCF because they have the same units. So if they had different units, what would we have done?
You must convert them to the same units.
Oh,
an example I gave you, it was hours and minutes. So you convert them to the same units of minutes, and then you calculate. So in case here you find kilograms, grams, and what, you make sure you work in the same units. So here, you will notice that our highest common factor, or what we call the GC, some of you love using greatest common divisor, is going to be 2 times 3, which is going to be 6. Now, what does it mean? It means that we shall have 6 packages. Depending on what he has, he can only make 6 packages. So the highest number of packages he can make, there are 6 packages. But now, like I told you, be an extra person. Go on and find out, if he's to make 6 packages, how much of each ingredient, of each item does she need? Now I'll come here and I say, this was cooking oil, this was sugar, and this is salt. So to find out how much of each is going to I'm going to come here and I say, number of items in each package, or per package in each package. So how do we do it? Now I'll come and I say, for sugar, he has 12 packets. So I will say 12 divided by 6. So here for sugar, you'll have 2 packets per package. Then I'll come, what about cooking oil? I'll come and I say cooking oil, there are 24 packets. I divide by 6. So by 6, I'll have what? That is what? 4 packets per package. Then I'll come for salt. So salt, what do we have? We have 30 divided by 6. So what do we have? We shall have 30 divided by 6. These are 5 packets per item. That means that the 6 packages he's going to pack, in each of those packages, he will put sugar, 2 packets, cooking oil, 4 packets, salt, 5 packets. So he'll come here and he will make his package, whereby in his package here, let me say, this is the package he's making. He'll put sugar, 2 packets. This is sugar. Then it will come cooking oil, he puts 4 packets. Then it will come salt, he puts for them very many, 5 of them. So that will be 1 package. So it is able to do this for only 6 packages. So that means that even when they ask how many people he can invite, he can only invite or distribute to 6 people, such that everyone gets an equal number of packages. Now, I want someone to give us now a conclusion. Yeah, someone raise up your hand and you give us a conclusion. Nalubowa, Shakila.
Master, I'm not giving.
Yes? Yes, Shakila.
Master, I'm just asking.
Yes?
Wait. Remember when we were getting the group 4 and then 5, we never again as in divided those numbers. Why?
When we are getting the what?
The greatest common factor, 6.
No, here I'm dividing. Here, why I'm dividing,
Yes.
I want to give a good conclusion. because how many packages will he make from the items he plans to buy? But looking at the question, you are noticing that the question here in the scenario, they wanted you to find each of them gets an equal number of items. You have achieved that. What is the highest number of packages he can make? So here now, I want to just make a good conclusion, because I told you, you must look for what is going to make you an exceptional kid. So here I'll say that the highest number of packages he can make are going to be 60 packages. And then you go on and say, and for each package, she will put 2 packets of sugar, 4 packets of cooking oil, and 6 packets of salt. Now, that is what makes you an exceptional child. But for you, if you only stop at, you will need 6 packages. So if they are looking out for some extra mark to award you, if you conclude like that, then it means you are an exceptional one. You have looked far beyond. Hope that is okay. Yes, so that is how I want you to always conclude. Say, you will need the highest number of packages, 6 packages. And in each package, she will put 2 packets of sugar, 4 packets of cooking oil, and 5 packets of salt. So that one will make you an exceptional. Hope we are together. Let me know in the chat. Are we together, members? Are we together? Yeah. Okay. Now, I think I'm caught up with the time. There is this one also, but you are going to take for me, I think, can you take for me a screenshot? You'll try out in your free time. You're going to try out. This is the number I want you to try out. It's about the gym instructor. And when you look at it, I want you to just look through it quickly and you tell me which idea are we applying. Which idea are you applying on that particular number? I want to look in the chat. Which idea are we applying? HCF Cassandra, HCF Uthman, HCF, yes. So here, because it needs dividing, splitting. I told you the moment you see splitting, then the idea that should come into your mind should be what? Should be that. Allow me to end at this point. Let me pick Shina, a question.
Teacher, for me, I just wanted to tell you that I'm not in that group. I'm requesting to join you.
Oh, someone with the group link, kindly drop it. Someone with the group link. Hope people have taken a screenshot of this number. I had other numbers, but I had also this one that I wanted us to try out. Yeah, so what we are going to do, allow me that I end at this point. Yes, oh, have I saved? Oh no. Oh no. I have not saved this work. So bad. So bad. I have not saved. But it is fine. It is fine. I thought I would save it and people use it, but it's okay. It is okay. Okay. I think that's the okay. I have discarded the work. Okay. We are going to end at this point. We are going to end here.